computer, escape. Yep, so everybody got that. Let's make sure my sound's on so I can hear them if they come in. Okay. I'm gonna move here, blackboard.cod.edu. Okay, perfect. Well, we can do our tradition here. Save. All right, we'll start with attendance.
How did he not it? I don't know, I thought you already had it. Like in here, like it just goes with you, like it doesn't look like odd, you know? Thank you. Yeah.
Maul, you're supposed to be on Zoom. Are you on Zoom? 2 people, awesome. Admit all. Nikki, okay, so you're not here. You're excused. Jackie, you're here. Janet, you're not. Lewis, not here. That's the heck you're here. Hi, Ariel. Hi, Nikki.
Hi.
Everybody's on Zoom?
Not everybody, just 2. Did you want to go first, Nikki?
Yeah, that would be great if I could.
I got to figure out how to, I think if I mute you and then I enter Zoom in the other way, then mute that one. So there's a speaker.
Hmm.
Hang on. Hold on. I could even show the funny video that way. Sure. Launch meeting. They didn't install Zoom. Are you effing kidding me? I'm sending him an email. The guy that did that, sending him an email for sure. Join meeting.
On the desktop?
What?
You're doing the Zoom on the desktop?
I'm gonna have to, and then I gotta let myself in.
Why don't you?
Okay. All right. Ooh. That's a problem. Nikki,
Yeah.
you have host privileges, so you should be able to screen share. We should be able
Okay. Share screen. What? All right, I want that. Okay, are you seeing the slides?
Yes, we are. Now do slideshow.
Okay, got it. And can you hear me okay? Can you hear me okay? I can't hear you if you're talking.
Yes, I'm muting myself because there's an echo. Yeah, we can hear you fine.
Okay, great. All right. So chapter 1 through 4 review. So I kind of just wanted to go in order because it makes more sense to me to just kind of work through what, we learned first to where we are now. So I guess I think it would be helpful to start with like defining the statistics. The definition is there. And I kind of wrote underneath, like basically it's how we can calculate and make sense of the information that we're given, and to put like that information into like a measurable and quantifiable format, so taking just different amounts of like, oh, this and that, and how do they putting them in a way that makes sense so that we can like understand them through calculations and such, and see how they relate to each other. And so then we kind of talk about descriptive and inferential statistics. So the descriptive is used to describe the data, and we use it for a lot of quantifiable variables, meaning for variables that have to do more with numbers and stuff. And then inferential is used to like infer observations. So and it's used more to make like assumptions about populations versus like taking a whole sample from a population. It's kind of helps with like sample sizes. So there's like three levels of control when you're doing research, which has to do with manipulation, randomization, and comparison and control. So you want to you have two variables, the independent variable, which is being manipulated, and then the dependent, which is the control. So you want to have a random selection of a group, and then you want to have your two groups, one of them which you're manipulating, then the other one you're going to see how it compares to the one being manipulated. So that's kind of how the research method works. So then there's different other methods where there's quasi-experimental, which is like the first method, I talked about with the 3 manipulation and all that. But with quasi, there's an element that can't be changed. So like a biological gender or like the age of someone, you can't change the age of it. They're always going to be that. So that's something that can't be changed. So you're doing the experimental method with that. And then the correlational method is kind of like this. I don't know if you can see my mouse. It has the it shows how like two things relate to each other. So like, it doesn't say like the cause and effect, but it can say like, well, if this is increased, this will either decrease or increase. You can see how they interact with each other. Then we have 4 scales of measurement. So nominal, which is like qualitative data, which is more representative, if giving a number to represent like an adjective or describing something that has a label like an age or gender. Then you have ordinal, which is like order or rank. So like that's examples would be like a pain scale, ages like 1 to 5, or you could things like that where you're like rating something, or like class rank, things like that is what you would use ordinal for. Interval has no true zero, but it's distributed in equal units. So examples of that would be like debt, or intelligence test scores. Then ratio is going to be measurements that do have a true zero and are distributed in equal units. So things like income or like height in inches. So like the biggest difference between interval and ratio is that interval can go negative, whereas ratio, it's only from 0 and upward. Let's see. Oh, there we go. Right there. Yes. Okay. So then I have types of variables. You have continuous, which is measured along a continuum at any place beyond the decimal point. So discrete, which is measured in whole units or categories and is not distributed along a continuum. Then you have quantitative, which is like measured numerically and is collected by measuring and counting. And then qualitative, which is talking about things that are not numeric, but like things like kind of like adjectives, more like that's what qualitative is, versus quantitative, which is more like a sum or a number of something. Then going over chapter 2, we talk about the frequency distributions for grouped and ungrouped data. So The definition of frequency distribution is how often a category score or range of scores will occur. So we're talking about like, well, I mean, frequency, just how often something occurs. So then we have grouped and ungrouped. So grouped is a set of scores distributed into intervals. So where the frequency of each score could fall within any given interval. So the intervals are equal sized and they don't overlap. And then each score only falls into one interval. Whereas ungrouped is a set of scores that are distributed individually, where the frequency of each individual score category is counted. So then there's steps for the frequency distribution, which is finding the real range. Then you find the interval width, and then you would construct the frequency distribution. Then we talk about identifying percentile points and percentile ranks. So the percentile point is the value of a score on a measurement scale below which a specified percentage of scores in a distribution fall. So then percentile rank is the percentage of scores with values that fall below a specific score in a distribution. So these are, sorry, where I used to have a picture. I don't know where it went. Where'd it go? Oh, am I missing a slide? Okay. Well, I'm just going to move on and hopefully maybe I'll find the slide later on. So then we talk about graphing distributions and we show kind of continuous data versus like discrete and categorical data. So we talk about histograms, frequency polygons. I never know how to pronounce this, the ogives, and then bar charts and pie charts. So then these are just different ways of showing the data. Histogram and bar charts are very similar. The biggest difference is with bar charts is space between them. The frequency polygons are more like to show, man, what's the word? To show like spacing over time. The ogives, I don't know if you guys can see my thing. It's like shows, it's kind of like the trajectory over a space of time. And then pie charts are more for like percentage purposes. Then we go into chapter 3 and we talk about central tendency. So this is when we get into like the mean, median, and mode. So these are like the measurements for locating a single score that is the most representative or descriptive of all the scores in a distribution. So kind of talking about what is going to best represent the amount, like all the numbers in this set of scores, you know, what is going to be like, yeah, I guess representing it the best. So the mean is the sum of a set of scores in a distribution that's divided by the total number of the scores summed. The median is like the middle value in the distribution of data, and when it's like listed in numeric order. And we use that usually for like skew distribution and ordinal scale data. I think I have an image of skew distribution in a minute. Then we talk about the mode, which is like the number that occurs most often in a set of scores. So they kind of like serve depending on what you're adding up or what the scores look like. You use the mean, median, or mode to understand that data. So here it is, the skew distribution. So this kind of shows when it's in the middle and symmetrical, the mean, the median, and the mode all line up. And when it's positive, it's going to lean towards the mode. The median is always central, obviously, and then the negative, it's going to like the mean's going to be on the inside. So you can kind of see there. I'm not very good at explaining it in technical terms. And then we talk about chapter 4, which is on variability and summarizing data. We talk about what variability is. So it's a measure of dispersion or spread of scores and a distribution and ranges from all the way from 0 to infinity. So we don't go into the negative numbers here. And then what range is like finding the largest value and the smallest value in a data set. And that is calculated by taking the largest and subtracting it by the smallest. And that's how we find the range. Then we use quartiles and interquartiles to kind of help us find different we use them for finding ranges or for calculating variability. So quartile is just quart, meaning like 1/4 of the data set. So the interquartile range is the range of values between the upper and lower quartiles, which is calculated by taking like the third quartile and the first quartile, and you subtract it from each other. You can see on my screen, or hopefully you can see it. Variance is the measure of variability for the average squared distance that scores deviate from the mean. So like talking about how, well, I mean, we're talking about how much they deviate. So we're trying to like measure how far, how much there are kind of outliers, or like scores that don't kind of line up within the set list of the scores that are there. So then we have different equations that we use for population versus sample variance, which is like the squared sums over n, or the computational formula, or like this one, which is the sum of x minus the mean squared over n. And then the sample is very similar, except it's just over n minus 1. Then we talk about standard deviation, which is how is the difference of each score from its mean. So if the mean is in the center, it's how far it's going to go in a given direction. And I think that, oh yeah, I have this. And this has to do with the empirical rule. And there's like the percentages of how much would fall outside of that mean, saying like how far it's going to go out. I believe that's all my slides. I think that's my last slide on that. Overall, yeah, I think the chapter 1, if we're talking, I know that some of us did it kind of in order of what they understood the most, what they understood the least. I would say that if I was going to say which ones were like more or harder for me to understand, it would probably be in probably be a little bit in like I understand. Oh, where is it? Oh, probably just talking about the percentile points and percentile ranks. As you could see, I thought I had another slide on it, and I was a little struggling to explain that. That's probably where I like struggle the most. So I understand it when we're like doing it within, when we're doing problems though, it's sometimes trying to explain it on its own that I struggle though. So that should be, that's my presentation.
Nice job.
Thank you.
So I'm going to stop your screen sharing. Ariel, I got your message, and your voice is like gone. So if you present, I could be your voice, and that's you, Amal, right? Or we can have somebody. Yeah.
To be clear,
This is a face-to-face class, to be clear. Go ahead.
was this sitting presenting? Were we what we didn't know, like what we wanted to be cleared up, or what we knew?
You're supposed to present chapters 1 through 4 and your understanding of them, and start with the least clear, or you can go in order and move towards the most clear. And the idea is this: we start with a review session because it was due last night.
I thought you said yeah. Oh, no.
If there's something I need to clear up for you guys, I can do that during class today. That's fine. But the idea was like, we'd all have our different interpretations of what we understand. So we'd have like basically a review session from all of you. Then of course I clear up anything if we need to. But this is like my clever way of like doing the repetition. Like
Because if first accurate, the one we just saw
Mhm.
is what we're supposed to do.
Mhm.
I did not do it right. I thought we were saying, like, I thought you assigned this thing to us so you could help us review for the test. So like
yeah, because my thinking is if you're totally stuck on something, we'll go through it. But my idea was like, if you were talking about like the least clear to you, like the idea would be to like walk through that the best you can. If you're still stuck, then you just tell me, we work through it in class, and then go towards the easiest. So that way you'd be working through some of the material. But if you're unsure of something, between my own review as needed and or your other colleagues, I think you'll probably feel pretty clear about that before you leave today. The test realistically is probably going to be like either by this time next week or like over the weekend. And you guys, we can talk about the deadline so that it makes sense for everybody. If you all have schedules, work, etc. You get 2 attempts, I'll take the highest score. You do not have to take it tonight or anything. You don't want to take it soon because we've covered chapters 1 through 4. So I could go as far as a week out if that would help, or we can go like several days, like, you know, by like Monday, something like that.
How many questions?
Yeah. What was that?
How many questions now?
I think it's 50. But it's a limited time. But your test is not your test. And if you take the second attempt, it's not the same. Like, I know the pretest and the post test are like pretty much the same questions over and over again for review. The exam's not like that. It's randomized, but it's still the same content. Yeah, Hector. I don't think it does till either it closes. Oh, it might. I think it might, because it wouldn't matter because you get a new version anyways.
Oh, yeah, for me, the post test, it shows what's wrong, the question that's wrong, but it doesn't show the answer.
I think that's what the exams do too.
Well, it just says that you didn't get the points, so it doesn't say like.
Yeah,
what you answered.
Yeah, it doesn't show the answer that's wrong, but it shows that you got it wrong.
I'm pretty sure the exam does that too. But if you have a question about something, if you're like, I don't know why I got that wrong, I can always clarify it, work backwards, etc. So do we want to have someone on Zoom go or someone going to go? Okay. Let's see, let's do.
I submitted it twice, one of them was on the actual file and the other was in the link.
Okay. I can probably follow either. So what I'm going to try to do here is I'm going to,
Just flip them.
I think I'm going to just do one screen share.
Because if they're on Zoom here, can you just turn the computer to that computer?
I can,
Yeah.
or if I screen share, they'll see it on that one.
Oh.
I'm one exam, they're right there, okay. Yeah, attempt 2, see, I see the most recent one. This one.
Oh, okay.
Okay, so I download, or that's fine, if I go like this, and I go to like another tab, like that, and then if we, and I think if I just go back into Zoom, first, come on. If I go to Zoom and I go share,
Oh, yeah.
and I do the desktop, and then I go like this, I go back to
But we're going to presentation today, are we gonna, like, review a bit test that's upcoming? This is the review.
this is the review, but we can go over it, whatever you guys need. Like, I'm here to help you. So like, so we'll have you all present. And then if there's any questions on chapters 1 through 4, we'll do more review.
My PowerPoint to review. I'm screwed.
You can
No
upload and change that. This is you. No, that's not you. Oh, come on. Exam 1.
And I can just go away from one.
Slideshow. So now, and I can show off the video if you want. So if you just click
Oh,
or scroll,
okay.
it'll broadcast them both,
Okay.
and they should be able to hear you.
Okay.
Let's give Jackie
the floor, everybody. So this is my review.
Guys drinking in the front.
This is my review for chapters 1 through 4. So 3 common research methods are the experimental, which is cause and effect, with a random assignment and a manipulated variable. And then the quasi with an experiment group, such as age, gender, something that cannot be changed and does not have a manipulated variable. And then we have correlation method, which tells us the strength and direction of the relationship between 2 or more variables and lacks control of the cause and effect, meaning that it can't really control what the outcome is going to be. And then some vocab is reliability, which helps us measure the consistency of the results, validity, which allows us to know if we are missing the variable correctly correctly, if we're measuring the variables correctly, sorry. And then single blind, which is the participating guests do not know what is happening, but the person giving the experiment does know. And double blind, which means neither of the groups know what they are getting. And then quantitative means that it varies by the amount, and qualitative means that it varies by the form or class. And then we have the NOR, which is N nominal scale of measurement, which meaning the data recorded at the nominal level being things such as gender and race. Ordinal level of measurement, meaning the number of spaces between each number. Interval variable, when there is 0 to 0 and the distance between each variable is equal. And ratio level, meaning absolute 0 and the distance between each variable is equal as well. Classification of variables, there are two types. First one is continuous, which means it's measured by at any place after the decimal, and then discrete is the whole numbers only. A little bit of chapter 2, we'll learn about the charts. Bar graph, which is a graph that shows qualitative class on the horizontal axis and class frequency on the vertical axis, with space between each bar, just like the top example over there. And then a histogram is the bottom example, which is the class on the horizontal axis and class frequency on the vertical axis with no space between the bars. And then a pie chart, which is on the top example, shows the percentage of each class represents. And then a frequency table shows us how often something happens. And then frequency polygram shows us the shape of the distribution with the line segments connecting the points, similar to a histogram. And then just this bottom example. Yes. Yes. Wait, right here. Okay. You're welcome. Steps of summarizing the group data. Find the real range, which means the difference between the largest number and the smallest number, and then adding 1. Step 2, find interval width, which is the real range divided by the number of intervals. And then step 3 is to construct the frequency distribution. Cumulative frequency, if it says add from bottom up, if you see words like less than, at or below, or at most, and then you add from top down if you see words such as greater than, at or above, or at least. And then some more vocab. Relative frequency means distribution portion of scores, and then you add each interval and divide by the total frequency, often used to summarize large data. Relative percentage distributes percentage of scores in each interval, multiplied by each relative frequency by 100. Sum of the relative percent equal to 100%. Cumulative relative frequency just distributes some of the relative frequency across series of intervals and can either be summarized bottom up or top down. Total sum of the related frequency is equal to 1.0. Percentile rank, short for PR, percentage of scores that values that fall below specific score. Percentile point, short for PP, cumulative score of critical interval. Critical interval, short for CI, includes significance, specific score or percent. Real range, upper limit is if it's more than 0.5, and then lower limit if it's less than 0.5. Steps to find the percentiles. First, you identify the critical intervals, then you identify the real range. Real range includes upper and lower limit plus 1. And then step 3 is find percentile point, subtract the critical percent rank from top interval, then multiply fractions by width of real range, and then you identify the percentile point. We also learned about the stem and leaf. So the stem being the first digit of the number. For instance, like in the number 20, the 2 would be the stem, and then the leaf would be the 0, which would be the leaf being the remaining digit or digits. And then chapter 3 was about central tendency, which means measurements tend to be towards the center of the distribution and mainly used to locate single will say single score, most representative or descriptive of all scores and distribution. 3 types of central tendency. There's mean, meaning the sum of scores divided by all the number of scores. And then median, which is the middle value when listed in numeric order, represents the midpoint. And then 3 being the mode, which is the value that occurs most often. Difference in notation. Population size is the uppercase N and sample size is the lowercase n. Some characteristics, mean is the normal distribution of data, which means median and mode fall into the 50 percentile. Median skewed distribution of data when data includes group scores that fall above positive skew or below negative skewed, mainly used to describe data. Mode distributions of data. Then we have the unimodal, means 1 mode. The bimodal means 2 modes. Multimodal means there's more than 2 modes. And then the non-modal means that there's no mode at all, or just represents something or someone. And then here I have an example of the different types of skewed that we have. We have the positive skewed, symmetrical skewed when everything falls into place, and then the negative skewed. In chapter 4, we learned about the variability, which measures the dispersion of data ranging from 0 to ongoing. And then facilities divide data sets into 2 or more equal parts. Median splits data in half. Quartile splits data into 4 parts. Deciles splits data into 10 parts, and then percentile splits data into 100 parts. Quartiles term, so if it's in the 25th percentile, it's a low quartile, and we use the Q1. If it's in the 50th percentile, we use Q2, and it's a median quartile, and if it's in the 75th percentile, we use Q3, and it's an upper quartile. Variance. Variance is how much scores vary from mean or average. Population variance is the SS divided by the N. Sample variance, supposed to be a capital N. And then sample variance is the SS divided by the lowercase n minus 1. SS just means the sum of the squares. And then degree of freedom is all the numbers are free to vary. Standard deviation, take the square root of the variance. And then some characteristics of standard deviation is 1, always being positive, used to describe quantitative variables, and most informative when reporting with mean. Exam time. And that is it.
So the exam is, I was gonna say, do it over the weekend. The latest I could go is like this time next week. So if you want to talk about deadlines, Zoom folks too, we can do that, but we need to take it soon just to keep clipping along. So is there any concern about the next several days? Do you guys need the full week? Talk to me.
The full week. Yeah.
Okay,
I'm not gonna do it. 100%.
so we're gonna say Wednesday by midnight
Yes.
of next week. Have it in. That's,
Are we ever gonna do a test like in class?
no,
So the final's online.
Yeah. because I'm giving you unlimited time.
Oh, and one more.
So it wouldn't make sense to take that in class. Sometimes I administer tests in class, usually has to do, well, maybe not for this class, but it usually has to do with like how awesome the class is. If their behavior is not so great, then they take tests in class. If they're awesome, I might do take home. By the way, yeah, go ahead.
Oh yeah, the questions on the post test, are they gonna be like some of them from the questions on the test that we're taking like in a few days, are some of them gonna be from the post test?
Probably not. It's gonna test, this is gonna test you, us is gonna test you on chapters 1 through 4. If you feel comfortable with WebAssign, you feel comfortable with the pretest and post test, chapters 1 through 4, as well as what we're going over today, you're probably just fine. It's content. It's a bank of like 500 questions or 1,000 questions, each get 50, and it's randomized, and no one gets the same exact test. But it's just chapters 1 through 4. Not only are the answers randomized in terms of like your A, if you guys got the same one, is not, could be like Jackie's D, like in you. Open book, open note, limited time, highest score wins. of the 2 attempts. So if you fail it and ace it or ace it and fail it, you would still get the A. What you
Okay.
can't do, just to be clear for everybody, do not take the test and walk away from Blackboard. That will be a problem. That'll burn one of your attempts or both of them. As long as you're in front of it in one sitting, you're fine. Blackboard will time you out. Now, you said there's something where you can save and come back, save your answers and come back. If Blackboard lets you do that, that's fine. But open book, open note, I would use the resources that I'm giving you. I'd be very cautious about Googling any resources. Because they might be wrong.
Someone,
Yes. I saw you have a study guide open for chapters 1 and 2. Yeah, I emailed those all to you guys. I think I posted those too. Do
Mhm.
you want those again?
I don't want to.
Did everybody get that?
Yeah, it's also on that thing.
I think they're on Blackboard too. I could email you guys again if that would be helpful. Chapters 3 and 4. Send email. All student users. I got you, Ariel. Hang on. Send you guys study guides.
Like for,
Not for the exam, for the chapters.
wait, for like.
So apparently everybody has 1 and 2. Apparently you guys do not have 3 and 4.
I don't even know what that is.
I got it from Blackboard.
I think they're in Blackboard, but I can email them to you guys. You gotta give me a second, but I can do that. Chapter,
Are you talking about the PowerPoint presentation?
no,
what do you think about?
I'm talking about the stats study guides.
Man, if only we
I
had-
don't think, I'm in chapter 1, I don't.
if Only we had an opportunity to review.
You know,
We're doing that right now.
This is a very- this is a very good review, but if we make mistakes, like in the presentation, they're gonna correct us.
Chapter 1. Like the thing on variance was probably better explained by Jackie than Nikki. Because it's how much scores vary from each other. Chapter 1 study guide. Submit. You guys should all have an email. That's chapter 1 study guide with a bunch of vocabulary. Maybe I have some formulas in there. Chapter 2 study guide. We'll do that one next. And we'll go chapter 2 study guide. You guys getting emails, by the way? Did that work? At your COD email?
Yeah.
So that's chapter 1 and 2. And then I'm gonna do 3 and 4. So give me just a second. We'll go. I don't have study guides past chapters 4 at this point. It doesn't mean that I couldn't create those. It just means they don't currently exist right now. Study guide.
Should we get our email right now?
I would recommend it.
Cause I did not, oh yeah.
Statistics, chapter 2 study guide. There you go. There's chapter 2. And we'll do chapter 3 and 4 right now. Chapter 3 study guide. Should have,
Tests in the future,
what?
for any of the tests in the future, are we gonna have to, like, go on FPSS or like?
Oh, yeah.
Excel And do it ourselves?
Uh-huh. That's totally gonna be a thing.
If say I failed, whatever he's talking about.
Well, I've shown you, I've given you all the formulas.
No, I know, yeah. It just, FPS looks good.
Why not? We're gonna use it more too.
No, in class, it's a lot easier.
That is a skill, by the way. Knowing how to use SPSS. Like employers will hire you for it. I don't just mean like me teaching this class, like knowing how to use SPS is like a thing. It's kind of like
Do
the
you have a
industry
guide?
standard.
On how to use it,
Yep,
SPSS, so nothing to do with stats, nothing to do with anything, just SPSS?
that's in the classroom.
No,
You want me to show you where that is next? I'll screen share. I'll show you where that is.
SPS is like entirely stats.
I mean, you can use it for other things.
It's kind of just stats. I don't think you'd use it for anything else.
My brother used it for.
Stats? No.
Yeah, it has nothing to do with,
What does he use SPS for? That's not stats related.
I think inventory.
Oh,
That which would involve stats.
yeah, it's just stats up here.
Yeah. Chapter 4 study guide. So I'm doing this all via email, just so it's easy for you all.
Why is nobody here today?
I don't know, because I still might do a funny video.
You didn't do a funny video.
No, because we jumped right into it.
Nice, I'm gonna miss it. Thank you to the student that emailed us in the beginning of the semester saying. Oh, yeah. He said he's, the class is also going to be online.
Which I can do because it's my academic freedom, but. Okay, so now you guys should all have study guides, even my Zoom folks.
Let's see. You just sent.
I sent them through, sent them through Blackboard.
Sent it for you.
I sent them all just now. More chat. Okay, I sent them to everybody via email, so
Until we get to chapter 4.
you should get it pretty quickly. Anybody get chapter 4?
Yeah, 1, 2, 3.
Then I just sent 4 through email.
Here,
Ariel says she got them, so
I got it.
got it. Okay, so now you have study guides for me too. A lot of that's vocab, but there's a few things where I have like some formulas and stuff in there. Okay, so let's answer Hudaifa's question.
What was my question?
Question on your post test 5. It's like messed up.
Oh, yeah. I had to
Oh, yeah,
guess
that's
it
due
was
tonight,
science,
right?
Just to get the right answer. On what? On one of the questions. for
Is-
questions.
So but then you got the highest score then, whatever your last score is, what got posted.
Yeah, I'm just letting you know it's like messed up. or something.
The,
What do you mean?
There was no picture.
So it says like, suppose a worker is selected to manage a state work, like affiliation, type of job and motive.
Actually, I think it's.
And then it's just like, there's supposed to be a picture and it's just not there. So and then
Yeah,
it says,
there's no
given the
picture.
workers a Democrat, what is the probability?
That's a good picture.
You can't figure out.
I believe you. It's under chapter 5.
Yeah, chapter 5 post test. Can you just give me the answer? No, seriously, like, I don't wanna have to go through this.
I
a million
memorized
times.
it. You want the answer?
What the hell is wrong with? That's part of learning. The following. The breakdown of workers,
Yeah, no,
that was like crap. Why did that come in so weird?
Yes.
yeah, I think you should just tell it to me. I can't-
Can I say the answer? I know.
Sure.
It's it's a 0.526.
Yeah, that's right.
Save me some time.
Professor,
I gotta figure out why I did that, because these are supposed to be, imported and it's never done that before. I might have to like re-import it or something.
Professor,
Yeah.
Pre-test 5 is due today. Post-test 5 is due today. WebAssign 5 is due today. Pre-test 6 was due yesterday, right?
Yes,
And then
that's right.
nothing else due this week, right?
Oh, I'm gonna assign more stuff,
Oh, no, this week.
not through today.
Ending this Sunday. I think this Sunday. Nothing is due.
I'm probably gonna assign post test for 6. Probably gonna assign WebAssign 6.
Okay.
And any worksheets you do in class, and I'll probably say have this done by like next class period. Like that's probably what's coming realistically. That should really be it. So you said you wanted to know where stuff was, so
Oh, yeah, the whole rundown on how to work SPSS.
we'll run down on how to work SPSS. So share screen, desktop, share. Student resources, right here.
1 second, let me go back.
Student resources. Your exams are right here, by the way. That's where they're housed.
Them right now.
General resources. SPSS tutorials. Everything you would want to know about what you can do with SPSS. And if you go back to the other folder under general resources, those are all your formulas. You have all your formulas you would need for chapters 3 and 4, and you have all your formulas for the entire book right here.
You should sell this whole thing right here. Seems pretty good.
I only sell my own copyrighted material. I don't sell publisher stuff. That'd be plagiarism.
Do you have anything?
No,
that's
no, because
copyrighted?
right now you said this
Yeah.
is your stuff. The whole rundown on SPSS, how to do it. You made it, right?
No,
Oh.
I imported it.
What do you
The
have?
worksheets, when we start getting into the worksheets, especially like probability and beyond, the second worksheet, I made it by hand.
Man.
Chapter 6, I made by hand. Chapter 7, chapter 8.
It's a lot more.
Yeah.
A lot. I feel like you make a lot.
I
Very
do.
smart.
I do make a lot of money.
How do you wait, what do you have copyright?
Not a mafia boss, Hudaifa.
What if he's like a
He's
special?
probably a money launderer. Oh my god.
I'm not Ozark, and I don't make that much money. I don't make like what you would think, okay?
How would you do it?
Using stats. Let's land the plane,
Okay,
gentlemen.
but be honest. Do you know how to like theoretically, do you know how to launder money?
I do not know how to launder money.
Dang.
I have a regular, normal career.
Okay, but that's what he would say. if He's trying to get away with
Gentlemen. All right, so Ariel, if you would like, you could present and I could be your voice. Do you want to like text me or communicate through Zoom on that? Or somebody else in the group could present theirs. But I'll be happy to like read your slides if you have something to present. Unless it's gonna like crimp your style. Do we need to see the funny video? I need to do that?
Yeah, when it's here.
You guys want to watch a funny video and then we'll go back to math here? Okay.
Good, good.
This is adult humor, guys. Okay, so I'm probably gonna, I'm gonna pause the. Ariel, you should have the ability to screen share. And was there a message? Chat. Okay, so I'm your voice, right? That's the plan? Or are you talking? Either way. You're still with us, right, Ariel? Okay. Yep. Okay, perfect. So the screen share should appear in Zoom because you're co-host. Okay, get it set up. Got it. I'm running out of stuff. If I can make it the whole semester. I'm running out of funny videos. I have to like do some research on some more.
No, you got. You gotta find 9.
That's his daughter, by the way, so she's not corrupted. That's like his daughter.
Yeah,
Okay.
yeah.
And I'm sure there were cue cards. All right. Like
I wonder how.
she's 2.
That was what, 2013.
Oh, she's like a teenager now.
Man.
She might have some problems,
That
huh?
was so weird.
Wonder how she talks now.
She turned into a cop.
That was the same.
Comes like-
There's another video you showed us where she's like.
You missed that one. Can't get the screen share to work. Did you put it in Blackboard? If you put it in Blackboard, I could go retrieve it. Did you upload? Because if you did that, that's easy. That's like, I can screen share on my side. That's no big deal. Exam 1 review. There you are. I got you. Yeah, you really missed out on that one. You can Google it though, the landlord.
Landlord baby.
Can't watch it now, but you can save it for next time. That's one is this you. Apparently, I think this is what I'm looking for. Okay. Oh, so you just texted me? Hang on, what'd you say? Chat. That's fine. And that'll work. And I got that. I got you. If I need to talk for you, you just gotta tell me, okay? So like type talk for me or, let's see, what do you say? Very dense slides, that's fine. Are you using your mic or am I your mic? I can talk, gotcha. Okay, this is Ariel's. So stats exam review. She's having problems with her voice, I guess. Yeah, that's fine. If you only produce a whisper, don't worry about it.
Maybe you can hire her.
What?
Like if you go, I think you go to her. Like,
No, she has like a thing with like not feeling well.
Oh,
That's why her voice. So quartiles, interquartiles, measure broken up into 2 or more parts because we're cutting things in half. Variability measures for dispersion, like ranges from 0 to infinity. It's how much the scores vary. It's never negative. So if there's one score that's different, that's your variability. Variance, the variability square distance scores deviating from the mean. That's right. All scores included. Value same as variability. Standard deviation, measure of variability or variance. Take the square root, used to summarize continuous data, but not categorical data. Central tendency, a descriptive summary of data set through a single value that reflects the standard data distribution. That's right. Mean type of central tendency. When we're saying central tendency, we're talking about the like they're either here on this side or that side. Like basically, the central tendency is where the scores sort of fall, and then we measure them 3 different ways. Your mean, that's like your average. Some of the scores, over n. Weighted mean combines 2 or more groups of scores that are unequal. We had that video on that, the weighted mean. Median, middle score in the data set. So like, if you have like a ruler, you move like towards like the middle. Mode, the value that covers the most often. So the mode, if we have 1, 1, 2, 3, 5, 5, 5, 8, clearly the 5 would be the mode. Let's see what else you have here. Chapter 2, frequency, how often a category score range of scores occur. Cumulative frequency distributes the sum of frequencies across a series of intervals. That's right. Relative frequency distributes population proportion of scores in each interval. Percentile describes how a score compares to other scores from the same set. Quartiles, observations into 4 defined intervals based on the values of data, how they compare to the entire set of observations. Ungrouped data given as individual points. That's right. Group data given in the form of intervals or could be class intervals. Relative percent, difference between 2 points. Discrete data, numerical type of data, including whole, concrete, numbers with fixed values, continuous data, complex numbers, and varying values measured over a particular time interval, and continuous. It goes on forever. Chapter 1, populations and samples. Population is a whole group. That's like all of you in the class. Sample would be like, do these 3 women represent with these 3 guys? I think probably not. I probably want like 2 and 2. Quantitative variables varies by amount. Types of research methods, experimental, that's cause and effect. Quasi-experimental, we're observing something, we're not manipulating anything. Like we're not suddenly changing your culture or your religion or your political affiliation. But we might measure your views on something. And then correlational method, that is the strength of the variables, -1 to +1, that's how much they move. So they move inversely, they move like this. The example I think I used was there was 83% correlation of high amounts of vitamin D in the UK versus severe cases of COVID. Does that mean that high levels of vitamin D protect you from COVID? Not necessarily. There just happens to be a strength of the relationship, which would be like 0.83 in terms of what the decimal would look like. Qualitative variables, form or class, like a label or an adjective, like male, female, age. I think the example I used initially was a doctoral student that she did a study on why people leave gangs, and it was all these descriptors of like how they reported that for qualitative variables. And that is your presentation, Ariel. Nice job. So who else is ready? Like to go next? Okay. Marina. Scully. There we go. Review, and then I should be able to go like so you should go just like, oh, hang on, system chat. Oh, yeah, no problem. Gotcha. Okay, yeah, just use the mouse or the keyboard and that'll control both screens.
Okay.
Or you can use the gray scroll thing.
Ah. There you go. Okay, the four scales of measurement in order from least informative to most informative is nominal, ordinal, interval, ratio. The nominal are measures numbers that represent something or someone, example, age, gender, religion, something that you cannot change. Ordinal are measurements that convey order or rank alone. For example, the rank of movies, restaurant, or the rank of pain. It can be in decimals or space can be vary. Interval scales are measurements that can have no zero and distributed in equal units. Example, rate of temperature, IQ test, grade levels. The ratio scales are measurements that have a true zero and distributed in equal units. Example, weight, height, income, number of children. Population parameter is a characteristic that describes a population. Example, a psychologist review her notes for all of her patients and determined that on average, her patients completed therapy in 24 days, the average time to complete therapy among all the patients. A qualitative variable varies by class and a quantitative variable varies by amount. Randomization, comparison, manipulations are all needed to conduct a study using the experimental method. Histogram, and I have like the histogram, like all the charts down in the below. Histogram, frequency, polygon, and ogiven are all of types of graphic display used to summarize quantitative continuous data. Bar and pie charts is a type of graphic display used to summarize qualitative discrete data. And if a teacher measures the time in seconds that it takes a student to complete a basic reading skill test, a histogram chart would be the most appropriate to summarize the frequency of children falling into different intervals of time. Lower boundaries are 1, 14, 27, 40, and 53. The upper boundaries would be 13, 26, 39, 52, and 65, and the difference from one to another is 13. And then I have a little chart here that shows the cumulative frequency distribution table. So, okay. So like to calculate this, we're gonna start from the bottom. So it's 3, and then 3 plus 3, it's 6. And then 5, we add the 5. So it's 3 plus 3 and 5 equals 11. And then so on until we get to like 45, where we add all of these numbers. And the mean and median tend to be at the center of binomial distribution. The median is used to describe an ordinal scale of measurement. So we can see here in the chart, the mean would be 4.6 because we added all the time and then divided by 5. Yes, 5. So it's 4.6. The medium is the number in the middle of the list, so we can see it's 5. And the mode, the value in the data that appears the most often, which would be 5. The principal wants to keep this is an example, the principal wants to keep a record of how many times they entered the lab. The following is a record of how many times the student enters the lab over a week, so n equals 5. And then, so the data is 12, 19, 23, 15, and 26. So we would add all of those up, which gives us 95, I'm sorry, and divided by the n, which is 19. And that's it.
So we have you or one of the gentlemen or Mal, who would like to go next? Okay. Women are just dominating, guys. What's up?
I get it wrong. I mean, doctor, I get it wrong, so.
Do you have stuff that's correct that you can show us?
No, because I swear to God, I thought the whole time was show what you don't understand, so.
I mean, that's something.
Maybe you go at the end.
Yeah,
Why don't you
yeah,
go?
we
Why
can all figure it out.
why don't you go at the end and then we'll either help you collectively and or I'll help you individually.
Okay, no, because I.
So we'll review everybody
Yeah.
and then you review all the stuff that like isn't clear to you. And you can tell us as you're
What I did was-
presenting if the review at this point has not made it clear to you or has made it clear to you. So if you're like, I get this now, tell us that. If you're like, I'm still freaking confused on this,
Yeah,
we
what
will
I
help
did
you
was
or I will help you.
Chapter, like, what I did was chapter 1 and 3, I put all the stuff that I was confused about, from chapters 1 to 3, everything else. was
Okay,
fine.
yeah, well, that'll still work for review. Because we'll help you be more clear. That's fine. Andy, where are you? Nina? Esther, here we go. Sam 1. So if we have a PDF, by the way, this is something pretty cool that I just learned last class. You just right click that and it looks like PowerPoint.
Walk us through it.
So I just click the arrow.
Just use the arrows or the mouse. If the arrows don't
Okay.
work, then use the mouse. Okay, perfect.
So chapter 1 was introduction to statistics. So statistics is used to summarize, organize, and analyze data. And then the two different types of statistics is descriptive, which shows a clearer presentation of data summary like tables or graphs. And inferential is researchers can make inferences about parameters in a population based on a sample of data. So it's like thinking about inferring. Population is the entire set of individuals or items of interest. Sample is representative part of a population. For example, doing a survey for a school that has a population of 4,000 students, but it would take too long to do the survey with each student individually. So we grab a sample of 200 students and have them do the survey. Qualitative data tells a story, while quantitative data is all numbers related. And then the independent variable is the cause, and the dependent variable is the effect. And then the three common research methods are experimental, which is a cause effect analysis. And then the quasi-experimental is there's no change in the independent variable. And the correlation is analysis for prediction. And then the reliability shows consistency. Validity shows if it's being measured correctly. And then the single blind is like when students don't know they're being experimented on, but the observer does, while double blind is neither the students or the observers know. And then the nominal, ordinal, interval, and ratio variables. So the nominal is represented as labels or names. For example, like Moji's father, president, that's names, labels. Ordinal numeric variables that are the only ones that are ranked, so like class rank. Interval is equal distance between each variable, and there is no absolute zero. So for example, 2, 4, 6, 8, and then the ratios also has an equal distance between each variable, but it's an absolute zero. So for example, height in inches or income. Chapter 2, summarizing data. The bar chart shows qualitative class on horizontal axis and class frequencies on vertical axis. Pie chart shows the proportion that each class represents out of the total number. Histogram shows the classes marked on the horizontal axis and the frequencies on the vertical axis. Frequency polygon, it is similar to the histogram. It consists of lines and shows shape of distribution. Frequency table is a group of qualitative data, and frequency distribution is a group of quantitative data. And then so range examples. So it's like 50 minus 20 equals 30, but with the real range, you add one. So if you do 50 minus 20 is 30 plus 1 is 31. The interval width is one more than the difference between the largest and smallest valuable. So that example, so like 30 plus 1 equals 31, and then you divide it by 10 and it's 3.1. And then the interval boundaries are the upper and lower limits for each interval in a frequency distribution. Lower boundary is the smallest value in each interval of frequency distribution, and the upper boundary is largest value in each interval of a frequency distribution. And then chapter 3 is the types of central tendency, which is mean is the average, median is midpoint, mode is value that occurs often, and then the differences in notation. So like the population size, it would be a capital N, sample size would be a lowercase n. Compute mean example. So I put 8, 4, 6, 4, 4, 10, 10, 6, and you add those all and it equals 52. And then you divide it by 8, which is how many numbers there is, and it's 6.5. And then the weighted mean is combined mean of 2 or more groups of scores. The number of scores in each group is unequal. So the capital M equals mean of each sample, and then the lowercase n is sample size, which is the weight of the mean of each mean. And then median is the middle value in the data that is listed in numeric order. So I put down as an example 2, 4, 6, 8, 10, 12, 14. The midpoint is 8. Mode is the value that occurs often. So all a bunch of numbers. The mode is the 9. And then I was confused with the skewed. I put that on that I was confused with like the positive, skewed.
Oh, it has to do with the median and the mode fall.
Okay.
And that's what basically pulls it to the left or right. I can show you an example.
That would be
again,
great.
Where you mark them, but it has to do with where the sentences are.
Okay.
And I can show that to you maybe before that presents or after you present.
Okay.
That'd be-
And then chapter 4 is summarizing data variability. The variability of scores are never negative. Variability is 0 or variability greater than 0. The range is a difference between the largest value and smallest value. So example 2, 4, 6, 8, 10, 12. So you do 12 minus 2. And then I did another one, which is the 20, 30, 40, 50, 85. So 85 minus 20 is 65. And then I did fractals divide data sets into 2 or more equal parts. So the median splits in half, the data in half, quartiles split data into 4, deciles split in data into 10, and percentiles split data into 100. And then the percentile terms are the 25th percentile is a lower quartile. Oh my God. Sorry. 50th percentile is the median quartile. 75th percentile is the upper quartile. And then how to locate each quartile on the data set. So you locate the median for all of the data, and that's the median quartile. And then step 2 is locate median for scores below, which is the lower quartile. And then locate the median of scores above, which is the upper quartile. And then I did the interquartile range, which is the 75th percentile, which is minus 25th percentile. That equals your quartile range. Semi-interquartile range is the it's computed by dividing the interquartile range in half. That's it.
Awesome. Nailed it. So we have. So when you think about central tendency, you think about the skewing of the data, it has to do with where the mean, median, and the mode fall. So this is a normal distribution because they're all gonna be on top of each other. But then if we look at, don't worry, guys, I'll screen share, Zoom folks, okay? So we go here and we go. Images. All right, and. Yeah, absolutely. Yeah, been out for about an hour, sure. Yeah.
Okay.
Yeah, we'll do like a 5 or 10 minute break. That's fine.
Me too,
Do you guys need one for the alcohol to wear off?
Okay.
So. All right, and let's stop the video. So do you see this right here? This is the skewing. So when the mean median is has to do with, so they're all on top of each other. You're negatively skewed, your modes to the right, your medians to the left of that, and then the mean is to the left of that. Your positive direction, modes first, median, and then mean. Another example would be like. Here's a better one. So the central tendency like basically pulls and modifies the curve because of where the average, like I want to say averages, but average is wrong because average is the mean. So there's central tendency. So the average is the mean, the median is like the midpoint of all the data. The outliers don't affect it, but that's like the central tendency, like where the score is trending. And then you have the mode that's repeated the most. And then wherever they fall defines the shape of the curve. Does that help or do you want like more? Ish, okay.
Oh, wait, before you exit this picture. See how in the left thingy, it says mean, median, then mode, and then on the right it says mode, median, and then mean.
Yeah.
So does it matter? I don't know how to say this in English. So you know how it says in the left one, mean, median, then mode. Let's say, for example, it's in this order, it's mode, then mean, then median. Does it, for it to be labeled as a positive or negative, does it have to be,
The mode has to be,
okay, wait.
like it literally pulls on this based on the data.
Does it have to be in that exact order every time? Mean,
Yeah.
median, then mode?
Yeah.
Every time.
Yeah, that's what we do that, yeah. Yeah. Now, there's stuff like multimodal. If something's multimodal, obviously, if something's multimodal, it's gonna look kind of like this.
And whatever's towards the bottom of the slope, that's usually the mean, right?
This is multimodal, okay, like that. That's when you have a bunch of modes. So your skew just, so that's a bell curve, right? That's like your normal distribution. And then whenever it's skewed is what we're just looking at right here, which is like desktop. Like that.
And the one that's like towards slope towards the bottom, it's usually the mean, right?
Well, when it's skewed, the mean's over here. So your average, so this is affecting the shape of the curve.
Yeah.
So it's because when they're all on top of each other, they make the curve perfect and it's balanced. But when they're like this, like your mean's over here, that's making it negative, median mode. And the same thing here, but if you notice, you see like some similarities. When they're skewed, the mode is at the very top. And then the median is to the left of that. And then the mean's to the left of that for negative. And this is the positive. It's like In other words, so it's literally just shaping the shape of the curve. The empirical rule that we've been talking about where it's 68%, 95%, 99.97% of the standard deviations, that only works with a standard or symmetrical distribution, doesn't work with skew distributions in terms of how the scores fall. Does that feel clearer? Do you want more stuff? Should I give you some more images? No pressure. I'm just trying to make that make sense for everybody. This is the one that you guys have all been using. So that's maybe a better picture. So the positive or negative skew, like, can you see how like, here's your bell curve, but then like all your data falls kind of to the right for your positive skew. Like most of it's right here. There's not a whole lot going on over here on the left side. Symmetrical, I think that one's pretty straightforward. That's just 50% of the data is here, 50% of the data is there. And then for the negative skew, because of where these fall, most of our data is over here. Like it's unbalanced, it's skewing it. In terms of like where the numbers are below the curve. Clearer or more? Okay. Okay, cool. Awesome. Well, it's either somebody on Zoom, but you just texted me that you can't present till a little bit later, and we're gonna take a break. So gentlemen, you're up after the break.
Yeah.
Are we doing 5 or do we need 10? Everybody. Bathroom? What's that?
You pick,
Let's say 5 because we got a lot to cover.
yeah.
And if we do 5, we can potentially take 1 or 2 more breaks, but we start taking longer breaks. It's harder to, because we don't want to lose a half an hour or 40 minutes, you know, of breaks. Just hang out soon, folks. I got your message, Jamal. That's fine. I might get like something.
Let's drink some.
I'm gonna pray for your time management with God.
Sorry?
I'm gonna pray for your time management. We're praying with that, okay?
Listen, we're going into winter. It's actually, the prayer, the one I just prayed, for winter it's called war prayer. In the sense of, now that winter's here, the sun, goes down early. So so that one, it starts at, we have like. It's vastly probably. I don't wanna say, I don't wanna speak. I was gonna say Colorado, but I would want like, I saw this really. And like, as the really the speakers from different backgrounds. Interesting. They both are, yeah.
For real.
They lost their game. 2-1. We lost 2-3. Because nothing in the week is fun except watching a game. So annoying. I actually want them to win because this school, bro. Our team? No, we're so bad. We could have won this. They threw. Tomorrow I'm gonna smack all of them. They have another game tomorrow. It's their last game tomorrow. They're not gonna win. They're absolutely not gonna win. How did they lose that? They were up 2-1. And they scored an own goal. We scored an own goal.
I like your enthusiasm as a sports fan, because you're not out there in the field, but I like your enthusiasm.
No, I'm complaining about my little brother's game.
Oh,
I don't care about FIFA. I hate FIFA.
Oh. Okay.
I want to smack them all.
so it should be Hector or Andy next, right?
I'm at the end.
Yeah, you're at the end, yeah, because then what you're gonna, because then you can present last, and then we'll either collectively or help you if we all know the answer, and or all
I mean,
alternate if it's something that's
I think
really
so far
confusing.
both of the stuff I checked are clear, but I'm gonna say what I think it is. If I'm wrong, you'll correct me.
Can you do that too? Let's see here. Yeah, you are right here. One review, come on, open. Dedicated to Hudaifa.
Yeah.
Oh, okay. Really support your homies. I'm impressed. All right. Go like this. And then I think Amal's gonna go last, I think. Slideshow, we should be able to hear you. So I'm just no echo. Play from current slide. All right, so it should just be like this or arrow keys.
So this is my exam one review dedicated to Hudaifa. Chapter 1, a lot of my info comes when I review for tests, I go through the PowerPoint, so it comes pretty much straight from the PowerPoints. Descriptive statistics summarize and organize scores. Inferential statistics allow sample results to be generalized to representative populations. Population is an entire set of individuals or items of interest. The data is termed, parameter, so population parameter. A sample is representative of a subset of a population. And then there are 3 kinds of ways of collecting research: experimental method, quasi-experimental method, and correlational method. So there's different, stuff like this, nominal.
Sure, a little different than my stuff. It's supposed to be your own creative version, not identical to the PowerPoint.
When I review, I would pretty much just I'm just doing what I do for a review. So this is what I'm presenting to the class. There's nominal, which is identity or classification. So some examples like male or female. Other examples, so like in high school, like you have sophomore, or actually no, that's not good. So like class, like upper class, middle class, high class, that's nominal. Ordinal is rank or order. Interval is order in equal units, no true zero. Ratio is order equal units in absolute zero. And then we got continuous versus discrete variables. Continuous is measured along a continuum, measured at any place beyond the decimal point. Discrete variables, which is separate in indivisible categories, whole numbers only. Then we have quantitative versus qualitative. Quantitative varies by amount, while qualitative varies by former class. So yeah, and then get into some chapter 2 stuff. We have grouped data. Group data is set of scores distributed into intervals. Frequency of each score can fall into any one interval. Is your hand raised? Or you just, okay. Interval is discrete range of values within which frequency of subset of scores is contained. We got cumulative frequency, distributes sum of frequencies across series of intervals. You add from bottom up, so you discuss in terms of less than, at or below, or at most. You can also add from top down, discuss in terms of greater than, at or above, or at least. Relative frequency distributes proportion of scores in each interval, equals frequency in an interval divided by total frequency count, often used to summarize large data sets. Relative percent distributes percent of scores in each interval. Now you get it, multiply each relative frequency by 100, and sum of relative percent is equal to 100%. Cumulative relative frequency distributes sum of relative frequencies across series of intervals, can be summarized from bottom up or top down. Total sum of relative frequencies is equal to 1. Cumulative percent, sum of relative percents across series of intervals, presented from bottom up, percentile rank, and the cumulative percent equal to 100%. Finding percentiles, identify individual rank by converting frequency distribution to cumulative percent distribution. So I've got your percentile point, question or percentile focus for each problem, value of score on scale below which specified percentage of scores in the distribution fall. You got your percentile rank, percentage of scores with values that fall below specified score. Yeah, your critical interval includes significant specific score or percentage deemed important. On to some chapter 3 stuff. So your goals for chapter 3. So sample mean only considers a selected number of observations drawn from the population data. The population mean, on the other hand, considers all the observations in the population to compute the average value. The mean average of a data set is found by adding all numbers in the data set and then dividing by the number of values in the set. The median is the middle value when a data set is ordered from least to greatest. And the mode is the number that occurs most often in a data set. An important property of the mean is that includes every value in your data set as part of the calculation. For nominal data, you want to use mode. For ordinal data, you want to use median, and then for ratio and interval data, you use mean. Chapter 4 stuff, quartile ranges of scores split into 4 equal parts. In the percentile terms, your lower quartile is the 25th percentile, the median quartile is 50th percentile, and the upper quartile is 75th percentile. The variance is the dispersion of scores from the mean, so you calculate the sum of squares first, divide it by the denominator, and that's how you get the population variance. So the population variance is the sum of squares divided by the population, and then sample variance is sum of squares divided by the divided by like the population minus 1, or the sample minus 1. Got the measure of variability. The average distance scores deviate from the mean, calculated by taking square root of the deviance. Or variance, my bad. And then how you find the population standard deviation, take the square root of the variance, and then so that's sum of squares divided by the population, or if you're looking for the sample standard deviation, you take the square root of the sum of squares divided by the sample minus 1. You got the empirical rule, we can't leave it out. At least 68% of all scores lie within 1 standard deviation of the mean, and at least 95% of all scores lie within 2 standard deviations of the mean, and at least 99.7% of all scores lie within 3 standard deviations of the mean. And some characteristics about the standard deviation is it's always positive. got the scores, and the negative variability is meaningless. Standard deviation used to describe quantitative variables. It's got a numeric value and it describes variables measured in numeric units. And the standard deviation is most informative when it reported with the mean. So reporting mean and standard deviation, it can inform a reader of distribution for close to all recorded data, report as mean plus or minus standard deviation, and the value for standard deviation affected by value of every score in distribution. So adding or subtracting same constant to each score will not change value of standard deviation. Multiplying or dividing each score using same constant will cause standard deviation to change by that constant. There you go.
You want to elaborate why it's dedicated to the DIFA?
I do
No,
like it.
I sit next to him in class. Me and him both are kind of struggling together, so it's dedicated to him.
And you did my geography class last semester.
Yeah. So
You're up, Hector.
I was kind of looking for where I don't know, I didn't know how I was supposed to go about it.
I think that's getting easier for you.
Does it feel easier from the review? Because that should be happening, hopefully.
No, I think the main issue was just the class themselves here.
Oh.
The term, SPSS,
Oh,
it's
but,
fine now.
okay, good, good. So all those texts like earlier this last several weeks that you're kind of feeling a lot better. Okay, good, good. Yeah. Hang on, I just wanna screen share. And then Amal, can you go next? And then Hudaifa?
Okay.
Yeah. No, we got one more person on Zoom. I think she can go next, but we'll see.
Chapter 1 through 4 review. This is mostly vocab. I didn't do many formulas since we were gonna get the formula page,
Okay,
all right,
that's fine.
or maybe I did. I don't know. I forgot what I added in here.
Okay. Walk us through it, it's fine.
This I started with descriptive statistics, procedures used to summarize, organize, and make a sense of set of scores called data. Presented graphically in tabular form, tables or summary statistics, single values. Inferential statistics were procedures used that allow researchers to infer generalized observations made with samples to the larger population from which they were selected. Research methods, experiment. They use some methods and procedures to make observation in which a researcher fully controls the conditions through like manipulation, randomization, comparison control. Independent variable is the variable that is manipulated in experiment. So I forgot how that one goes. The dependent variable, the variable that is measured in each group of a study, and it is believed to change in the presence of the independent variable.
Independent variable is something that we're manipulating, like remember the Dr. Java study? Where we're like, do they take caffeine or not? So we're trying to see if we change something, like you have an experiment, and you have a control group, and we're trying to see if it makes sense. We're not going to talk about the words policy.
Okay, quasi-independent variable, a pre-existing variable that is often a characteristic inherent to an individual, which differentiates the groups or conditions being compared in a research study. It cannot be manipulated like I don't know if this example was right, but I said that
I think that could be culture, gender, age, political affiliation, all quasi-independent. Something I cannot tell you, Hector, to suddenly change your culture, however you were raised, whatever deeply seated beliefs you believe. You're not randomly going to switch over to Hudaifa's culture which might be different than your own or mine, because we're all raised differently. I can't fundamentally tell you to be a Democrat or Republican or conservative if you've already picked a side. So typically it's something we can't change to make it quasi-independent. That make sense?
Yeah.
Okay, cool.
Scales of measurement. Nominal scales are measurements in which a number is assigned to represent something or someone, like, for example, gender, right? Like male or female. Ordinal scales are measurements that convey rank, like the place you finished in a race, first, second, or third. Coding, the procedure of converting a nominal or categorical variable to a numeric value. So like I said, like man could be number one or woman could be number two. Interval scales are measurements that have no true zero and are distributed in equal units. I said Fahrenheit temperatures are in a thermometer starting at like 0 degrees to 10 degrees, or if you were going down from 0 to -10, depending how you used it. Intervals are between 5 to 20, which is recommended. Ratio level measurement, measurements that have a true zero and are distributed to equal units. I said a Kelvin scale has a true zero, and you can't really go under 0 degrees on the Kelvin. So like with the Celsius, I said, I guess it would be for 0 degrees Kelvin would be the ratio to a -273 degrees 15.15 Celsius. Since I think it can't go, I think that would be like the ratio. So like 1 to the ratio, 1 Kelvin to the ratio of 272.15 Celsius.
That's a ratio. The ratio variable is, the type of variable that's shown in ratio value is absolute zero. What you're talking about is like a ratio to something else, and that's not incorrect. But what we were talking about was ratio is equal distance between each number, and it's basically an absolute zero. What you're talking about is like a ratio between numbers, which is slightly different. Not wrong, just like it's not a racial variable. Does that make sense?
Yeah. Okay, discrete variable, measured in whole units or categories that are not distributed along a continuum. I think I said the number of teachers you have for the semester, which is like, I don't think you can have more than, like maybe you have like 4 teachers. You can't have like 3.5 teachers. Okay. Number of pencils in a package, like 12 maybe, can have 11.5. Continuous variable is measured along a continuum at any place beyond the decimal point. It can be measured in fractional units. I don't know. Pi, I guess, would be a continuous variable, but I don't know if I did that right either. I don't know. Height, I don't know.
More continuous variables, more like income, because you can make 0 to anything. Like it goes on for a long period of time. I wouldn't say you're wrong with pi. I get what you're saying. But generally it's like start somewhere and it's like more than one number. It's not just like by itself for a continuous variable. Like that, there's like behind you, if that went to infinity, that would be a continuous variable.
Okay, yeah.
Yeah. So you're very close to say pi.
Oh, okay. Okay. Quantitative variable varies by amount. This variable is measured numerically and is often collected by measuring or counting. Number of books in a library would be a quantitative variable. Qualitative variable varies by class. This variable is often represented as a label and describes non-numeric aspects of phenomena. The words used to describe how it was to go on a skyfall, right?
I don't know if I fully understand your analogy.
Like it was thrilling, or like
Oh,
it was exciting.
Oh, you're talking about like falling out of the sky, like skydiving. Gotcha. Yeah, it's exciting. Qualitative variable. Yeah, like an adjective. Yeah, you got it. Yeah, that's right.
Frequency, the number of times or how often a category score range of score occurs. Example, the number of times you come to school in a week, in a normal 16-week semester. Okay. Group data, data set into intervals. Ungroup data, a raw set of scores not put into any orders. Real range data is one or more the difference between the largest and smallest value. Is one more than the difference between the largest and smallest value in data sets, like 50 minus 25 equals 25, which would be 25 the range between those two. And then you would add 1, so you would get 26, and that would be the real range. The interval width or class width is the range of values contained in each interval of a group frequency distribution. Interval width equals real range divided by the number of intervals. For example, 26 from the real range up there divided by 5, the number of intervals, equals to 5.2 interval, which is the interval width. So you would round to the nearest whole number, 5, and the interval width would be 5. Lower boundary is the smallest value in each interval of frequency distribution. Example, 10 to 20 interval, and 10, number 10 is the lower boundary. Upper boundary, the largest value in each interval of frequency distribution. 10 to 20, the interval again, 20 is the boundary. Open interval is an interval with no defined upper or lower boundary. I couldn't understand that one, so I didn't get an example for that one.
So that means like, there's no, like, open interval means that there's literally like no top or bottom. Like you basically have an undefined interval. Yeah, because if you don't have a lower boundary, like there's not top or bottom.
Okay.
Does that make sense?
No.
I've never seen, where did you get open interval from?
The book, I was going through the book while making the study guide.
Okay, yeah, that would make sense, yeah. I remember talking open interval, I think, in class. Yeah. Yeah, so
Oh, yeah.
there would basically be like, so it'd be like an interval that's unclear, really.
All fives? Or what?
Well, it's saying there's no upper or lower boundary, so I don't think we would use that ever.
Also,
I don't think we would ever use that because it's not an interval by itself is like, it's defined top and bottom. So although that's a thing, I don't see where we would use that very much in stats.
Yeah.
Maybe you were trying to find. I'm not sure how we would use that. I don't think we use it very much at all. But if the book says it's there, then
yeah, it's fine.
I'll assume the publisher got that right, but we really don't. You guys should have thought of that.
We don't.
No.
Okay.
The other stuff that's on your slide, yeah. I don't think.
Okay, outliers are extreme scores that fall substantially above or below most of the scores in a particular data set, which would I mean like would be like 1 through like 10, and one of the numbers is like 90. 90 would be the outlier. Cumulative frequency distribution, a summary display that distributes the sum of frequencies across a series of intervals. Frequencies add from bottom up. Relative frequency in percent. Cumulative relative frequency in percent. The frequency total is 45. So and get the frequency in an interval and divide it by total 45. I forgot how I did this, but from what I remember is like the relative percent is equals to 100%. The total cumulative relative frequency will add up to like 1.00. Total cumulative relative percent would add up to 100% too. I just
Remember what we do with rounded cumulative percent. If you round the whole time, you adjust that last number so that you get to 100, not over 100%. You guys remember that?
Yeah, I remember, but, You said it just the last number, the one before.
Before you get to the 100.
Wouldn't that like mess with the data of it? The last
Or,
number.
or no, actually, no, the last number that you should go 100% is the one that you modify.
Yeah, so if you tamper with the last number.
It's because you're rounding. You can't go to 101%.
Yeah, but wouldn't that last number be tampered with, so they wouldn't be,
Well, because you're rounding, you tamper, because you're rounding. You're trying to get to 100%.
okay? I mean, cause like, what if, like, let's say, for example, you do something and everything is like 2, 3, 4, 5. The last one you, the data itself is, 2, or like, sorry, it's like 6. But then you have to round it down to go to 100 and it's sure it's 3. So wouldn't the data be tampered with, would be as accurate?
But it's because you're already tampering, you're already rounding. So what you're doing is when you round down at the end or up so that you get it right, is because you've been rounding the data the whole time. So you're adjusting so you get to 100% because if you round, you don't want to be more than 100% because then it wouldn't make sense. So you take that last number and then you round it up or down so that you get to that 100% total. Because you rounded, if you don't round, you're right, then you would have a data tampering problem. But because you're rounding the whole time, you have to round one more time if it's applicable, so you get to the right percentage. Keep going, you're doing great.
Percentile point and percentile rank. I didn't really understand this, but I guess the percentile rank would be the highest score in this chart. And that only occurred once. So I don't know. I really don't understand this one.
I can walk you guys through that again, but like percentile rank, that's like your 85th percent, or your 85% of the class, like the percentile to everybody else. Because remember, percentiles equal to 100%. So it's like the rank, like where you're scoring, for example, in the class. Percentile point, I would say like a decimal, but I can walk through that some more after you. I can present, that's fine.
Okay. Mean, I'm in chapter 3. Mean average is a sum of a set of scores in a distribution divided by the total number of scores summed. Weighted mean combined of two or groups of scores. Combined mean of two or groups of scores where number of scores in each group are unequal. Multiply the sample mean by the sample size. Divide. I don't know if I wrote that right.
We didn't. I'm sure you're right either. It's where you basically, you account for how many in your two groups you have, and then you divide that accordingly and you add the two together for your weighted mean. So your mean is like everything, like, and the average. The weighted mean is like, we have 4 guys in class right now, including me, and we have 3 women. So the weighted mean would account for there's 4 guys versus the 3 women. So we would try to find like the average that way because of the weight, because like there'd be less women versus there'd be 4 guys. I can show you that again.
Okay.
I can review that. I have that video that walks through it. That I can show you guys again.
Okay.
But I don't, can you explain, I don't understand how you explain 4 of us, and how.
So if we say we have 3, 4, 5, 6, 7 people, okay, and we all have like a number assigned to us, you would take the sum of everybody divided by n. However, with weighted mean, we would take the sum of all the women, like the number assigned to them divided by n, and then that would be like one calculation. Then we don't have numbers assigned to us as guys. We take those divided by n, and we add the 2 together for the weighted mean. So if I said 170, 80, 90, we take those. Then if I said over here, I'm just talking about like random numbers, like we said like age. If I said we said all women are 22, 21, 20, 19, I don't know, young, okay? We'll keep saying young, smaller numbers, so that I don't think any women, okay? And then I said all of us were all like 70 or something, like because guys usually don't get offended by like age comments, okay? And then I would add those all together, and then I would get an average of us, of our age, I get an average of their age, and then I add the two together, and then I have a weighted mean, what would happen is, if we all had like high numbers, we pull up the mean more, there's more of us. If they had low numbers, they would pull the mean down, but there's less of them, so they wouldn't affect the mean as much because it's weighted. Now, if we had 4 women, and you all had similar ages, and we have 4 guys, it'd be pretty similar to the regular average. And so the weighted mean accounts for the differences in the groups. I think the example we used was weights, but I wanted to say like ages.
Wait, so weighted mean just shows the specific.
It shows the specifics of the average.
Okay.
So it accounts for like, there's more of us than them right now. Now, if I start thinking about my folks on Zoom, it might be a little bit more balanced out. So I think there's like, yeah, no, it would be the other way. This is all women on Zoom. So the weighted mean, so I was talking about the class. So if I said, let's account for all the women in the class and assign a value or a number against all the men, they would have more power in terms of affecting the average because there's more of them. Does that make sense? Always more powerful. All right, I'm glad. I can show you an example too if you want.
Measures of central tendency, median, middle value, and distribution of data listed in numeric order. Mode, most frequently mentioned number. Skew distribution. Skew distribution is a distribution of scores that includes scores that fall substantially above or below most other scores in a data set. Positively skewed distribution is a distribution of scores that includes scores that are substantially larger toward the right tail in a graph. A negatively skewed distribution is a distribution of scores that includes scores that are substantially smaller toward the left tail in a graph than most other scores.
That's what I said.
Use the same ones as the other ones. So, like, I had a question. Would it be like the same way he was saying it earlier? Mean, median, and mode on that positive
Yeah,
skew.
that's right. And then there's more numbers to the right. You see like your mean average. And that chunk, that triangle from the mean to the right, there's more of those and there's less where like the mode is to the left and like the median. And that's what shapes it. And then in the center, they're all the same. So 50% of all the numbers are on the left and right, and that makes the curve completely symmetrical. And then on the far right, the negative skew, there's more numbers to the left, and there's less numbers to the right. But for your question, yeah, it would always be in that order in terms of what that would do to. And there's really, the thing is, everybody, there's not really another option. You either have them all on top of each other, and then you either have the mean and the mode to the left or right of the median, or vice versa. Like, there's really not another way to do it in terms of how that would shape it.
Okay. Chapter 4, summarizing data variability. Variability is the measures of a dispersion or spread of scores in a distribution or spread of scores in a distribution and ranges from 0 to positive infinity. I said like 8, 8, 8, 8. I got this from the book. It has
variability zero.
variability
The
zero.
scores didn't vary.
How would you measure variability? For example, 8, 8, 8, 1.
So the variability would be how the scores are varying from 8 to 1.
I understand, but like,
Slight-
because he's saying has a variability of 0. Of course, 0 because there's no other number besides 8. But let's say there's 3 of the same number and then one different number. What would you say? Like, someone were to ask, what's the variability? What would you say? What would you answer?
You would talk about the variability, then you say the number, how do you calculate that? That's the sum of the squares over n, or the sum of the squares over n minus 1. So you would take all your values, you would subtract the mean from all of them. And then you get those numbers, then you would square all those differences. That would be your squares. You would add a little, you get the sum of the squares. And then you get the sum, you divide it the n of the population into the sum of the squares of the variability. And then that number would be what you would report for variability. Okay. And I can show you an example.
Yeah, that'll be helpful.
Okay. Range is the difference between the largest value and the smallest value in the data set. Lower quartile is the 25th percentile. I think you use this one. I think this is from your PowerPoint. And a median quartile, 50 percentile, and the upper quartile, 75th percentile. And these are the ones that I couldn't really explain because even with the definition, I couldn't understand it. That was all.
Was there someone else on Zoom that was going before me or?
I'm gonna find out right now. And I'll explain that to you. Amal, can you go before Hudaifa? Or do you need more time? You want to text me through the chat? Can you hear me? No, but someone randomly took a bong hit. That was not cool.
Oh, yeah.
Yeah. And I just stopped right in the middle of my lecture and I was like, if we cannot do that while I'm lecturing, I really appreciate that. Please don't take bong hits. And right back into the lecture. And they never, ever heard it again. Probably seriously freaked them out. I can make that work. That's okay. We can zoom in. We can zoom in them all. I need to make you co-host. I'm gonna unmake co-host for Ariel. So hang on. Okay, I'm gonna make you co-host. Now you should have screen sharing capabilities and we should be able to hear you as soon as you turn your mic on and as soon as you start screen sharing. And don't worry, I'll make everybody pipe down as soon as you're ready to present.
Okay, you can hear me?
Yeah, all right, can you guys hear her?
Hello?
I
Okay,
can go like this, but then we'll get an echo.
okay.
You guys can hear her okay, or does that sound weird? Ooh, that doesn't sound good.
It does, no. Hmm. So I did mine on, it's not a slide, it's the word, so that's how I was able to do mine. That's what I'm showing. Let me scroll up. Can you guys see this? Are you guys there? Hello?
Yes.
Okay. Okay, so statistics, it says here, I got this, most of my information, by the way, I got from either Google or Quizlet. It helps me kind of summarize into where I can understand better. And I started here statistics, a branch of applied mathematics that involves the collection, description, analysis, and inference of conclusions from quantitative data. For descriptive statistics, I said it summarizes the characteristics of a data set, and examples I had was either a chart or a graph. And for inferential statistics, allows you to test whether your data is generalizable to the population. And the example I found here was, let's say you're doing a survey and the researcher finds the average scores between women and men, and that differ with a p value of 0.03, 3% is what they said that was, that scores in the study and are due to random chance. The results are valid, is what they will say here, because the p-value is statistically significant, which is less than or equal to 0.05. Population I put is the entire group of individuals to be studied, and parameter is the numerical summary of a population's information from the entire group. And for sample, I have it as the subset of the population that is being studied, and statistics is the numerical study of a sample information from that subgroup. For the research methods, the three commonly used, I have a lot of words just to help me understand here. So the experimental method is a method of investigation used to demonstrate the cause and effect relationships And the purpose of basically they're manipulating or one factor thought to produce change in another, and it's fully controlled by the researcher. I was able to find an example for that. And the one I have here is where they're doing a study on people who, whether their sleep deprivation will impair the performance of their driving test. And with this one, the researcher will control other variables that might influence the outcome. So based on like if they had less sleep, if they had more sleep, so he's the one controlling that part to get the answers he's looking for. For the quasi-experimental method, I put research that involves manipulation as well of an independent variable without the random assignment. So among the important types here are non-equivalent groups designs, pretest process, and their interrupted time series designs. So another example I found here is like, let's say there's a researcher who's examining the effects of a caffeine or reading comprehension. She might randomly assign participants to one of the three independent variables. So those who drink 1 cup or 2 cups of soda or no soda, or, that's how it will be. And for correlational method, is a research design that looks at relationship between 2 or more variables. For this one, the studies are like non-experimental, means the experimenter does not manipulate or control any of the variables. Let me know if any of my examples are not matching. This is how I found it. An example for this one was either positive correlation will be height and weight. Okay, and taller people tend to be heavier. A negative correlation is basically a relationship between 2 variables, so in which an increase is in one variable is associated with a decrease in the other. Here I did find a picture from Google, so I'm not owning this. I stated the 4 scales here, so it is upside down from the greatest to the lowest, I guess. So if here, from the picture part, that's what it shows. So if you can see, nominal scale is also known as the classification scale because of the values of the variable, and mutually exclusive. And let's say the non-mole scales are qualitative rather than quantitative. So it like kind of represents something or someone. There's an easy way to remember that. And then ordinal scales are measured with numbers and representing categories that can be placed in meaningful numerical order. So in ordinal scales, the interval between values have no specific size. And interval scales in any range of values that have a meaningful mathematical difference, but no true zero. So the example for this one I had was like temperature, either Fahrenheit, Celsius, the scores or credit scores, SAT scores or credit scores. And then the ratio scale is the most informative measurement scale, and the intervals between adjacent values are equal, and there's a true 0 point here. The ratio scale is at a higher level than the interval scale here because the scale has an absolute 0 point. The researcher knows how to measure pretty much. So here the example was like weight. It's an example of the ratio scale because it has an absolute 0. And what else here? And by the way, I kind of mixed it up. I didn't know which one is chapter 1 and chapter 2. Sorry about that. And then here I was trying to distinguish between variables and that are qualitative or quantitative. And I said qualitative variables are non-numeric in nature and are summarized in graphs and bar charts. Quantitative variables are numeric in nature and can be either discrete or continuous in nature. And here, so the behavior, so this is an example of that. So the behavior of human is an example for qualitative variable, while the number of buses between 2 cities is a quantitative variable. Something kind of helped me remember later. So here I try to distinguish variables that are discrete or continuous. The difference between the discrete and continuous variable here is regarding the quantitative variable. A discrete variable takes on individual distinct values, and a continuous variable can take on any value within an interval. And here at frequency is how often something occurs. And the frequency distribution is a summary that tells how frequently or often values occur in the data. So here was an example. Let's say you're trying to do a survey. You ask like 15 people how many pets they have in their home, and there's results. You'll be like, "Oh, all the numbers I have here," and they add up to being 15. So this is an example here. And then this simple frequency distribution summary display, frequency of each individual score or category are in group data in distribution, or the frequency of scores falling within the defined groups or intervals, like the group data in a distribution. So here, I really don't understand what I just said. So I'm gonna ask for help later when I'm done. And then group data can be distributed as a range of values with upper and low values into intervals. And group data can be distributed as categories. What else? Cumulative frequency distribution is the total number of data items with a value less than upper limit. And cumulative relative frequency distribution shows the proportion of data items with value less than or equal to the upper limit of each class. What do I have here? Relative frequency distribution, I'm just kind of defining what I understand from that. It's a summary of data showing the fraction or proportion of observations. And the percent frequency distribution is summary of data showing percentage of observations, relative percent, and relative frequency summarizes the percentage and proportion of scores falling into each interval. For percentile rank, I said that's the percentage of individuals in distribution with scores at or below value. And to define mean, I said it's like the average where you add up all the numbers you have here and then divide by how many numbers that you had added up to get that. And for the mode, this is where I ended. I wasn't able to go further than this, but the mode is the most frequently occurring number, is what I put down. And I wasn't able to get anything else. I do apologize. I know I was trying to get some of the formulas in there and some of vocabulary, but with other circumstances, this is all I was able to come up with right now. I think that's all. Thank you.
Hang on. Go ahead, now she can hear you. Yeah, nice job. I know your situation, so no worries. You're up, Hudaifa. So Hudaifa's gonna present, and then we're all going to, if you get stuck, just be like, hey, guys, I'm lost, or I don't understand this thing. And then collectively or on my own, depending on kind of like where you're at, we will help you to get you to have a good understanding. And then we'll probably use some chapter 6 stuff today too, for sure. You right here.
Are we gonna do that, the one chapter?
The end of the chapter. Yeah, that's actually really easy. Yeah.
Okay.
Yeah. That's fine. but we're-
Attempt 1.
Oh. Yeah, so just do the best you can. And like I said, if you're totally lost or something doesn't make sense now, we'll help
No,
you.
but I'm gonna, what's it called, so everything seems a little more clear now, so I'm gonna explain what I know,
Okay.
and then if I'm wrong, you guys, anybody can correct me.
Yeah, we'll totally help you. Yeah. There is untitled. Watch, there you go, present. Okay, so give it a shot and you get stuck. We'll help you.
Okay, so this is the review for chapters 1 to 4.
Either the mouse
Is it
or
telling me
or
something?
or you can do
There we go,
this.
yeah, I got it.
You got it? Yep, okay.
Okay, so quasi-experimental, I think from my understanding now is it's like it's just an observation of something. So you're not changing anything. You're just you're discrete. No one knows what you're doing or where you are. You're just observing the thing you're observing. And then the difference,
manipulating any.
yeah, you're not changing anything. So you're just looking at everything, right? Observe.
So-
It's
so
just an
like-
observation.
Like. So, because you're pretty open about your faith, that.
Yeah,
you're-
go ahead.
You're a Muslim guy, okay?
Yeah.
You're very open about your faith. If I wanted to measure your attitude towards morality against like Muslims, Jewish folks, Christians, and Buddhists, that's a bunch of religions that are pretty popular, right? It would be quasi-experimental. Zoom book, can you even hear me? Maybe I should walk over by.
Can you guys hear him?
You guys hear me? Use my teacher voice, I can get a little closer to the mic. So it'd be, so if I wanted to see if attitudes towards morality vary between Buddhists, Muslims, Christians, and Jewish folks, I would be quasi-experimental because I'm not gonna suddenly make you Jewish or Christian or Buddhist, you're Muslim.
Yeah.
I'm not gonna suddenly make somebody else in the group a different religion, your religion sticks, just like political affiliation. So I would be measuring and observing like the attitudes towards morality and if there's any differences, but I wouldn't be manipulating anything which make it quasi-experimental, so I'm not gonna change anybody's religion. So that's where it's quasi, does that help?
Yeah, so it's just an observation, you're not
It's
doing
an
anything.
observation, and you still have an independent variable, but you're not changing anything with the independent variable, you're just seeing what happens.
Okay. And then correlation, let me give you an example. I think the more chocolate you eat, the happier you become. So you're just trying to make a correlation between happiness and chocolate.
Yes, but but correlation is not cause and effect. So what you might measure is levels of happiness and amount of chocolate consumption, and you might notice the more chocolate that's consumed, that happiness increases, but all we're measuring is the strength of the variable between how they move with each other. So we're not saying that chocolate causes happiness, we're just saying, oh, that's interesting, happiness seems to go up when you consume chocolate. See how there's like a slight nuance difference?
Yeah.
Okay.
And then the difference between validity and reliability. Reliability is whether it's not tampered with, the person doing the experiment is not biased, it's done correctly. Other way around, because I was gonna say validity is if you can do it more than once.
You reversed it. Validity
Okay.
is did you measure the thing correctly? Reliability is consistency.
So reliability is when you can do it more than one time and you get the same consistent results.
Yeah, so I think the example I used early on in the semester was like the stimulus checks were incredibly unreliable because they didn't show up every month.
Okay.
Over and
that
over
makes
again.
sense.
Validity, did you measure the thing the right way? Now, which one's the most important, validity over reliability? Because
Whether it was done correctly and
if you don't measure the thing right, it's already unreliable.
can you explain validity like real quick? Like an
So
example?
validity is if I want to see if, well, I think Dr. Job is a good example. We were trying to see if the caffeine was making their performance scores get better. And they all had similar grades and they all consume caffeinated or non-caffeinated beverages. So we were measuring the caffeine consumption against the scores. And we didn't really have a bunch of other variables influencing that, at least in like the scenario.
Yeah.
That's what made it valid, because we measured it the right way.
Okay.
Does that help?
Yeah.
Or you want- Okay.
And then Neuer, let me just, okay, so nominal, ordinal, interval, and
Yes.
ratio.
Yes.
Nominal is like president, father, mother, brother, sister.
Yeah.
Okay, and then ordinal is freshman, sophomore, junior, senior.
Ranking, sure.
Okay.
For how you're doing in the class.
And
yes.
then interval and ratio. Okay, the interval and ratio are the same thing, except one of them has like equal space between.
They both have equal space between. Interval has no absolute zero or it's an arbitrary zero.
Okay.
Ratio has an absolute zero.
Okay, so intervals like temperature, because it can go below 0.
No, that'd be, yeah, yep, that's right. Yep, that'd be interval. Yep.
Okay, and then ratio is like, you said it does not have no.
Has an
absolute zero.
absolute zero, so like income,
It does have an absolute. zero.
because you could make $0.
Okay,
You could be completely unemployed for a
debt-
year.
debt, your grades. Because you can't have, I mean,
Well, that's how much you owe.
yeah, but like,
So you could owe 0, so that'd still be ratio.
yes, so it is ratio.
Yeah, so that would be 0. Yeah, because there could be an absolute 0 what you owe. So it'd be a ratio.
Grades, because you can't go below 0.
Yeah, yeah, that would make sense. Yeah.
Okay.
Yeah.
Height, we said that before. Salary, we said that before. I mean, yeah, it's pretty much, yeah. Okay, frequency table. Okay, wait, frequency first. It's how often something is repeated, right?
Yeah.
Okay, and then a table just shows how the data for everything about a frequency.
Yeah,
Correct?
it shows how often it's it's repeated, yeah.
And the distribution, it's just laid out for you. It just shows how many times it is repeated.
The thing happened, yeah.
Okay. And then I said I want to learn how to do SPSS. You said that. You said you have like a whole thingy
Yep.
on Blackboard. STEM and leaf. I don't
Stem
know.
first number, leaf, the other numbers after the first number.
Wait, like 2 columns?
They're like columns.
It'll be the two would be the stem and the leaf would be the.
Oh, wait, is it always?
Stem,
always
Okay, yeah, that
Leaf.
makes sense. That makes sense. Okay. Why though?
that's just
How it is.
That's just how it is. Sometimes with math, they just make
weird.
up, they do the rule. Just like
Okay.
technically 0 divided by 0 is 0, because we don't really have a real good answer to this. You never really divide nothing by nothing, but we put a
When
Band-Aid
would
on
we
it.
use like this? STEM and leaf?
Rarely, once in a while.
Okay.
If you're showing data, if you're showing descriptive statistics in a stem and leaf display to show something, with descriptive statistics, you would use this. We don't use it a lot, but you could use it. Yep.
And then group data. Okay, let me give an example. Group data. 1, 2. This is grouped. Example. This is grouped.
Potentially, I would probably have more context, but keep going.
Yeah, and then ungrouped is X, Y, and then Z.
Yeah, like
So,
more or less, things that you have to like, that
Okay.
can't really be put together. would
so
be
group is
ungrouped.
just you put brackets around like a group of data. Ungrouped, it's everything by itself.
Yeah, and usually you can't categorize it. You have to categorize it differently because you can't really group it. Yeah.
Okay, yeah, because it seems that this example is not good enough. Can you give an example?
Or at the end, or you one out.
Okay, you know what, after's fine
Yeah.
because this seems not that hard. The equation one, you have a whole worksheet for that, and then I saw in the chapter 3 slideshow thing, you said you were like how to tell this. There was like some, correct me if I'm wrong. You said there was like some equation or something like formula you entered to know whether a table is grouped or ungrouped.
There's a formula.
Okay, then
I can walk through that.
Okay,
I'll
yeah.
walk through group and ungroup.
Percentile points.
I'm gonna walk through that in a second.
Okay. Graphing distribution.
Percentile points. Points. Graphing distribution, that's just doing the graph, but I can show you an example. What else do I need to cover?
Oh, I know, that's pretty much it.
These 2 percentile points on grouping.
Yeah, and then and
Group.
graphing distribution. as well. Write that down.
I'll pull up that worksheet again, and we'll walk through that.
Okay, well,
The
that's
one on, yep.
that's pretty much it.
Okay, all right, so we can cover that. Unless anybody wants to give him any point of help here.
Any of these.
Percentile points, gravity distribution, group or non-group. Any ways you remember that, or I can walk through it. Let us know if that helps you remember it, because the way you're stating it might be better than the way I stated it, maybe. Or-
Examples are
yeah.
the best thing. Yeah,
Yeah.
the best thing for me.
Okay.
Examples.
okay, we'll get there. While you're doing that, I'll pull some stuff up here. If you have something, great. If you don't even sweat it either way. Yeah. So graphing distribution is literally like just like graphing your data like in a chart or a table.
Oh, that's it.
Yeah, graphing distribution, showing like the display of the graphs. We got that one.
Oh yeah, and then histogram and bar chart.
Yeah, those are the ones that we talked about the most.
Bar chart are it's the thing with just a long whatever, and then the only difference is histogram is no space in between.
Yeah, that's right. I think you got it. these are scenarios for grouped and ungrouped data. Hang on, I'll give you some rules though too. Want to open group. So we have group data where your set of scores are distributed into intervals. So like where you can have sets of intervals and the frequency of each score can fall into any one interval. As an example, you share versus the difference, the nuance between grouped and ungrouped data would be right here, share, Microsoft Word, zoom in, and of course you can jump in at any point, Jackie, if you'd like to. So number one, we did the, oh, you want to jump in, Andy?
Actually, I just pulled that up.
So the time in seconds takes 100 children to complete a cognitive skills game. That was group data because we put the cognitive skills game, we grouped it into class intervals. The frequency of children would be distributed in each interval. So the time it's taking is how we're grouping that in our scenario. So the time in seconds it takes. So that's very easy to group the data. The number of single mothers with 1, 2, 3, or 4 children. That's ungrouped because we list them in classes because it's not the same. Like group data, we had time and it was very easy to sort time. We had trouble sorting the mothers, so we would have to look at the classes and the frequency of them would be distributed in each class because of how many children they had. So like that's not something that I can easily group. That's why it's ungrouped. The next one is ungrouped, but why is it ungrouped? So what do we have? We have 3. The number of teenagers who have experimented with smoking, yes or no. That's ungrouped because it's yes and no. Like it's an answer. It's like it's qualitative. Like I can't really, there's not like a time or something I can put it in for group data. Group data number 4 is the age and years of freshmen students at local college. Again, that's like a measurement of time. And that's group data because you can put the age in class intervals and the frequency or in each interval. Is that starting to click? Do you want some more examples?
Yeah.
Jackie's got something to help us or no? No.
These specific questions, I don't know.
For me, I don't know. Yeah, I kind of feel like, so like ungrouped seems to be like, it kind of seems to be like nominal stuff.
Yeah, that's generally the case. Yeah.
But then, I don't know. And then also, is ordinal the one where it's like, well, because like the number of single mothers with 1, 2, 3, or 4 children, it
That's
says that one's ungrouped. So like, that's not nominal.
it's just the number of mothers. But they don't have the same amount, they don't all have the same amount of children either.
Yeah.
So I can't group moms with 1 child. So if, yeah, this will work. This is ungrouped. Mom with 1 child, mom with 2 child, mom with 3 child, with 4. I can't really put this mom with more kids in a group with this mom with less kids or vice versa. That's why ungrouped. Does seeing it visually maybe help a little bit?
Yeah.
Is usually nominal, but you got to think of like, do the groups make sense to put them together? or do they not? This, we really couldn't, because they're not, now, if they all had, if it was mothers and they all had 4 kids, that would be group data.
Yeah, they're not all in the same group. They're like 180 war veterans. are all in the same group.
Yeah, you got it, yeah. Yeah. That's totally it. Does that make more sense, Defa? Okay. At least we did grouped, percentile points. Right? That was. What was that? Percentile point? I think that's in chapter 2. I can totally hear you.
We were just talking about consuming alcohol beverages.
You were talking about how much time is left in the class, what you're talking
I
about.
was talking about
Professor,
consuming alcohol
no,
beverages.
there's an hour left. in class.
Now in 9 minutes.
Ungrouped data, the set of scores, or you want to see that? It's for qualitative or categorical variables. Percentile point, where is that one? Percentile points. And this is that. Let's go like this. Percentile point, that's the value of a score on a scale below with the specified percentage of scores in a distribution fall. And percentile rank, or PR, is percentage of scores that fall below specified score. So the only difference is like, so the first one would be percentile point value of score in which a specified range of distribution fall. So if this is how you're doing in the course, that's your percentile rank, and maybe you're 85, maybe you're 70, maybe you're 95%. That's your percentile rank of how you're doing in the course, like your overall grade, where your percentile point is the value in which a specified range of scores and distribution falls. So the percentile point, percentile point would be like if we had these scores: 100, 90, 85, 70, 60. Percentile point. So the percentile point was 85, it'd be where those scores fell. It's like one number, whereas percentile is like where you fall in the percentage. I think that's everything you run clear about, right? Anything else? Group? Yeah, that's it. All right, let's jump into chapter 6. How's everybody doing? Good. Okay, so. Chapter 6, yep. Does more often. It's pretty awesome. I can control both screens. So probability, normal distributions, and z-scores. Normal distribution, of course, is when something's symmetrical. We're talking about some characteristics. Statistical norm, standard normal distribution, the unit normal table. That's going to be the other half of that worksheet, by the way. Locating proportions, locating scores, going from binomial to nominal, and a normal approximation, and then we're going to practice with worksheets. So normal distribution, that is literally, I think I erased it. That's the bell curve. Where the scores are more probable or likely, where everything's around the mean. Behavior data that researchers measure often tend to approximate a normal distribution. Usually, we're not really dealing with a lot of skewed positive or negatively distributed scores when we're looking at something, just in general. These are various normal distributions. As you can see, they're all bell curved, all bell shaped. I'm going to go back. Does that make sense so far? Distribution. This is also in chapter 6 too. So characteristics, mathematically defined, that's just how it is on the X and the Y axis. Don't really go into that formula. Behavior data, like I said, approximates normal distribution. So basically it's symmetrical. That's what we want to think about, the characteristics. Half of the data fall above and below. So that's half your data is here. Half of your data is here. That's your normal distribution. You do the folding test. If you folded it in half, it'd be a perfect distribution. If you like, if the crease was where the mean, the median, and the mode are half and half of the data. That's what that folding test means. The mean can be any value. Mean can be any number from positive infinity to negative infinity. The standard deviation can equal any positive value. So standard deviations. If this is intelligence and we're using Stanford Binet, I don't really believe in Stanford Binet. If you've had Gen Psych with me, this is intelligence. This is average intelligence. Everybody's usually about here. All of you are probably at least here or higher, just the fact that you're in college. You have deviations. Standard deviations, clustering of behavior. They happen to be in 15s with intelligence, by the way. 115, 130, 145, 30, 145, 160. You can do a lot more cognitively at each deviation. You can figure out a puzzle, you can figure something out, etc. Standard deviations have to do with how the data basically clusters or shows things behaviorally. So if you're not coming into this class rocking a 7, okay? Like that's not happening because you can't do as much cognitively as 100. You're probably not even here if you have 85. I believe just to go through K through 12, you have to do more than a 7. It has to do with measure, but if you're rocking a 130, a 145, 160, or 175, you can do a lot more because you're way above average intelligence. It's clustering of scores are what standard deviations are, which is the square root of the variance. These can be to the left or the right. This would be one standard deviation. This would be two standard deviations. Two standard deviations to the left of basically our mean here, or to the right. Whether you're to the left or right, you just talk about it positively. Standard deviation 1, 2, 3 places, and they go like that away from the mean. Total area under the curve is equal to 1 because it's 100%. Area under the curve varies between 0 and 1, can never be negative because you wouldn't have a curve then. Proportions of the area are used to determine the probabilities of normally distributed data. The tails of a normal distribution are asymptotic, so they never actually touch the x-axis, and that allows for the possibility of outliers. So what that means is, can you see that right there? It doesn't actually, what they're saying is, this never actually touches the x-axis, and these are your standard deviations. As you can see, those might be negative, but you talk about them just as a whole number. So just the left or the right. And this is, of course, this also has to do with the empirical rule in terms of where all the data falls. Because this would be 68% of the data right here. This would be 95% of the data. This would be that 99.7%. So listen in decimals, the empirical rule. Is that all making sense so far? Some of this is just review.
Yeah.
So we're going to say normal. Now I can say something like Gaussian, symmetrical, but we're usually going to say normal bell curve. Studying links between obesity and sleep duration state that short sleepers are at a higher risk of obesity compared to normal sleepers. What does it mean when researchers say normal sleepers? Well, the bell curve, that the data is normally distributed. So only about 5% of the data falls about 2 standard deviations from the mean. That's the empirical rule again, because of what I was just showing you. Yeah.
The
Wow. Or-
no, yeah, that's fine. So you know how it says right there, oh wait, the ones on the right and left, on the far right and left, that's the higher percentage?
So about 5% of the data falls in those spots, lower percentage.
So.
Because the data is shaping the curve. Like there's less
That's my question.
and less of it, there's more of it. Like we're shaping the curve, but all of it, the reason it's a bell shape is because half of it falls left and right. As soon as we don't have half on the left and right of the curve has to change its shape to show where the data lies. All right, awesome. So standard normal distribution. So what is a z-score? A z-score is normalizing the standard, just is basically a standard deviation. And what we're doing is we're taking a value and we're trying to predict if something happens based on a standard deviation. So what we typically look at is you're gonna always have like the mean plus or minus the standard deviation. And why would it be plus or minus? Because you can go to the left or the right of the mean. So that's always how it's listed. So a z-score basically says we take an x value, or we want to see if something's happening. Like I think I have a worksheet where we calculate the z-score as to whether or not the manager sends around funny jokes and if it increases employee morale. So we can take a value, we plug it in, that's your x or your value. We convert it to a z-score. It tells us what the standard deviation looks like and whether or not we can make an assumption in terms of our hypothesis. Don't worry, we're going to practice this. It's coming up. So the numerical value specifies the distance or standard deviation of a value from the mean. That's what your z-scores are. So you can see these z-scores right here. Mean is 0, a z-score of 1, standard deviation 2, 3. So this is an example of a normal distribution. Like I said, basically a z-score becomes a standard deviation. What is our formula? It looks like this. Z is equal to x minus the mean over the standard deviation. So we're going to write it x minus the Greek mu over basically theta right there for the population, or we're going to say x minus m. So x minus the, typically there's a new mean, like there's a new mean that we're looking at over the standard deviation. So the value minus the mean over the standard deviation. And then we're going to use this transformation to locate where the score would fall in the standard normal distribution. So we're basically plugging the value in and we're saying we subtract the mean from the value, we divide it over by the standard deviation, and that basically normalizes it into a standard deviation score. Once you know the location, the standard normal distribution rules define the probability of something happening. So for example, so for some application here, a researcher measures the farthest distance in feet that students move from the podium during a class presentation, much like what we just did just now the last few hours. The data were normally distributed. All that means is we had a bell curve. It was normally distributed with m is equal to 12, which is your mean, and the standard deviation is equal to 2. What is the score for x equals 14 feet? Well, you plug it in. You take 14 minus 1. Where do we get that from? Well, the mean was 12, and the standard deviation was 2. So we subtract 14 minus 1 by substituting the values into the distribution.
How does that equal?
Why is that? I don't know if I did that right. X minus m. That should, no. They did that wrong. 14 minus 12 is 2 divided by 2. That's a typo on the publisher. That should say 14 minus 12 because it would be the mean. X minus m is the mean. Divided by 2, which is 1. Z is equal to x minus the mean over theta, or z is equal to x minus m over the standard deviation. Therefore, 14 minus 12, not 1, this is 2, numerator, divided by 2, which is our standard deviation, equals 1. That's what they got. That's what you're looking at. So the z-score is 1 standard deviation above the mean. So we're just normalizing it. So what is that? So we're normalizing that. This is our unit normal table. I believe I've posted this, or I can email and post this for you right now in Blackboard. This is the other part of that worksheet, by the way. This is what we're referencing. You guys want to take a break and do that part of that last part of that worksheet? Because that's what the unit normal table is.
Wait, do it first, then a break.
Sure, yeah, because it's only like 5 things.
Oh, yeah, so should we do the part two?
Yes, let's do part two, yeah.
Oh, I was just wondering if we did that by yourself.
No, let's do that part right now. We'll take like a 5-minute break and then we'll sort of round out chapter 6 today. And then next week, we'll probably do 7 and 8. Approximately. We're still fine on time. I teach this course every semester. We always finish, we always have enough time. So let's do Blackboard. 2D. So statistics, that is this one right here. Oh, you guys can't see. Institution. Stop. Right here. And we did student resources. And we did in-class activities. And then I believe it was dated, the one that we did was 929 part B, I think was where we were, I'm pretty sure. Stats review homework, yeah, that's prob-
629. Oh, that's just the name.
homework 929 part B. Should look something like this. I think we had some probability in there.
Yeah.
And then in your own. So what we're gonna do is, we're notice that there's 3 columns in the unit normal table, A, B, and C. We're gonna locate the z-scores below this list of z-scores. We're gonna locate one in the unit normal table and write down the values you see in column B and C across from it. So all that means is we're literally gonna go in to our unit normal table, which I think is already in there for you. Share.
Oh, yeah, we're about to-
Hey, this is the one we were started last week.
Yeah, that's what we started last week.
Is it those numbers, the 1.5? Is that the?
Yeah, but it's, I think it's in the announcements for you guys. I'm pretty sure.
What was it called again? Part B or part A?
Part B, where's my Z? Oh, it's not there. Okay. That's fine. Great announcement. Z scores, Z table. This is also in our book, guys. Send a copy. Please tell me I can add it. Oh yeah, there we go. No, I can't browse. All right, so we'll do email instead. Send email. All student users, and we'll say Z table. Z table. And then the Z table should be like this. Come on, Z table. Oh, that needs to be 12.
Oh,
It's not 1.
where, on the standard deviation?
14 minus 12 divided by 2 is equal to 1. 14 minus 1 would not be divided by, would not be 12. Yeah.
On the like, with the standard form of distribution, it is on the x-axis, and then z-score value on the x-axis as well. One of them is y, right?
Yeah, Y is up and down, X is on the bottom.
No, they both say x-axis.
For the tails to not touch
Oh,
the bottom. Because they're asymptotic, if I'm saying that right, so they don't actually touch the x-axis ever. When you do the bell curve, so like
I do it.
this, like
So I do it, and it's like, one of them is this number, and the other one is this number?
this, we're saying the tails don't actually ever touch,
Okay,
like ever, like they don't actually touch it. Yeah, and then that's
this number and then this number? Like I'm on, it says z-score and standard deviation,
yeah, you're
but just from my notes, like,
yeah, that's perfect.
no, what is the same?
So we convert. Oh. So the the value on the x-axis. So what we do is we convert like a value, like an x, like a number, to a z-score, which tells us where the standard deviations fall. Like if I plug in a new value based on my mean, how do we convert that to a normal standard deviation? So we said in our example, x minus 14, we converted it to, that's right here, I think. We-
Oh, I see what you mean. Yeah.
We converted 14 minus 12, which was our mean, our mean, we divided by our standard deviation. And that got us 2. We got 2 divided by 2 is 1. So that means that we pulled that score in, it fell 1 standard deviation away from the mean. So then we can make behavioral conclusions based on that. That's making sense?
Yeah.
Okay. No problem. Z-scores. Hope you guys can still see this. So we're gonna go into general all statistics. I might have just left that in chapter 6, maybe. I think I might have just left it right there. Z table. You see that? So go into chapter 6 right here. Oh, I'm not screen sharing. Share screen. Desktop. Share.
Oh, is it the helpful Z-score table?
The hell? The helpful Z-score table. That's what we want. Okay. So you should have like the Z table right here. And then you should get like a document right here. That looks like this, Appendix C, or you can download it. Go chapter 6.
PowerPoint?
No, Z table.
Oh,
Go into the Z table. And then we're gonna find the values in A to finish out the other worksheet. And we're gonna write the B and C values that are listed next to the Z score.
Which page on, there's which page?
it's on
Chapter 6,
No, I understand, but I'm on the thing itself,
you're on the worksheet?
this thing,
Okay, so let's do that together as a group.
yeah, that,
Yeah, perfect.
so what page do you want us to be on right now?
So I'm gonna pull up this. So we're gonna write the B and C scores right here. So number 1 is 0.0. So if we go back 0.0, so we're gonna put these two are 0.000 and 0.5000 on the Z score, columns B and C. We're just looking them up.
Are we working on chapter 5 review,
Yes,
like 6?
5 and 6, yeah.
Okay, wait, so we don't edit this.
No, don't edit the table. The table's for your reference.
Oh, okay, okay, that's what I thought you were editing.
No,
And we're doing part 2?
part 3.
Oh, did we skip part 2?
Part 2 is you guys come up with your own probability, right?
Yeah. Come up with our own question. That was the
Oh,
homework.
Part 3, so all we're doing now is we're looking in this table, which I can zoom in if you want, if that's more helpful. So what's that first number for the Z score that you see on the worksheet?
0.00.
And what number do you see in the B and C columns to the right?
0.0009.5.
So we're gonna list those two numbers for number 1 on the worksheet.
So like, will we put equals or just?
Just comma, and then list it, and then comma, and then list the decimal for the B and C column.
Oh man, that's all.
That's all we're doing with this worksheet. That's it. So then the next one is what, like 1.96?
It's -1.0.
So you look it up, it says look it up as if it were positive, right? So we go back and it was 1.000, right? Is that right? -1. We're looking at it as positive. We're gonna find a +1 Z score. So we're just gonna go into our Z scores and we're gonna look at column A and we're gonna try to find 1. I found 1 right here. So we have 0.3413 and 0.1587 for our B and C columns. Does that make sense? We're just looking up Z score. I'll come around. I'll come around and they'll still be able to see it, okay? So if you look, so
so I have like.
actually, I'm gonna get my mouse because So if we go into. I don't see part C. So this right here, I'm gonna show you. You're chatting again, that's fine. Part A, I don't think you're seeing that. Chapter 5, stats review homework, it's titled this, but that was in 929 under in-class activities. So you have, so we did this last time, this was a review of the probability. And then if you scroll down, so you did your own, part 2 and part 3. So this first one, we went into our Z table right here, which is that right there, and we're listing B and C, comma, right next to them.
Oh, okay, so then it would be 0.124, comma,
0.5000, comma, yep, that's totally right.
and that's it.
Yeah, so this one's gonna be based on our Z table, 0.000, comma, 0.5000. So then this one is gonna be, that's just for, I mean, you can keep it there if you want. This one's gonna be 0.3413, comma, 0.1587. Now, where did I get that from?
Yeah, where do you?
So keep going, keep finding your Z score. No, find your Z score. You're right there. You see that Z score right there? 1.
Oh, wait, but then how come for this one, we did this one?
Because we're basing it off the Z score. So
So
let's say
then,
look it up as if it were positive. So number 2. So you're gonna look up 1. So you're gonna find 1 in the Z column. So scroll down because
so but like, for example, this one, we use this one. And then it's 0.15.
no, we used this to get those 2.
Okay,
So then we're gonna find number 1. So find
Okay.
1. And then number 1 is gonna be
there's two.
those 2, 0.3413 and 0.1587.
Okay. 0.3413, comma, 0.1587.
Yeah. So 0.99, we're gonna find 0.99 in our Z score, which is right here. So that's 0.3389, comma, 0.1611.
Okay,
Yes.
and then we're just like, for example,
I'm
the
just
negative
gonna come
one,
around and show you all how it's in there.
the negative 165, we're just pretending
It's
it's
positive
positive,
and then
right?
the same thing.
Okay.
So you got it.
Oh, okay.
A, right?
Yeah. Is it, do I need to send an email and tell them to get their act together with the heating and cooling? Because I totally will.
Why, what do you mean?
I thought you guys were saying it was cold.
Oh, no.
Oh,
Yeah.
okay, because I love giving the administration
No, actually,
crap when they
at the
mess
beginning
things
of
up.
the class, like, it was very, like, yeah, there you go.
It's very cool.
I told her, I'm like, I feel like putting a little heater in. Okay.
1.65, do we do the 2 columns next to it?
Yeah, B and C. So, like, so this one, the first
Uh-huh.
one, it was that one and that one. And then we need the,
These two, right?
yeah, no, this was the Z score, and then that's B and C. So you should have 0.0000, right, like this. My mouse not plugged in. My mouse won't work. Awesome.
No, you know what?
So the, oh, go ahead, yeah.
There was like a callback on the computers.
A what?
A recall, it's called a recall, no?
Oh,
That there was something was going on with the mouse and the keyboard.
on Apple recently.
Yeah. I think it
Oh,
was the book, right? Not the Air, the Mac. What's the
Great.
Pro? The Pro, yeah, that one.
which is the one. So like, so that was, this should be 4 zeros, but apparently I can't, it won't let me type it suddenly.
Okay, so we got it right here. Yes, these two.
Yep,
B and C. B and C.
B and
So
C. So it's 0.000
Point,
and 5000.
point. Okay, and then you look up if this is a positive 1. So I go all the way down to,
So you find 1. So you find 1 in your list of Z scores. So So it's probably somewhere in this column. You're not there yet.
Right here.
So one, so point, so
These two?
no, it's the B
Oh.
and C to the right.
Okay.
So that's 0.3413 and 0.1587.
Oh, wow.
That's all we're doing.
So just those two.
Just those two numbers to the
Okay.
right. Does that make sense? Should I go?
Yes.
Gentlemen, should I come over by you guys or does it make sense? You're finding the Z-score in the table. So you're looking at this table right here. Did that not share?
It would be these, right? The one above it? For the next one?
Yep, those two. Yep,
Oh,
that's it.
wow.
Yep, that's all we're doing. We're just. So if I do stop share and I do share screen. Desktop. Share.
It's 65?
So all we're doing, do you guys see that up there on the board? You're looking up the Z-score in column A and you're writing the number in column B and C to the right of it. That's all we're doing for the end of the worksheet. That's it.
1.5?
This is gonna make more sense later. We're just getting our feet wet to know how to use the Z table.
75.
Zoom folks, does that make sense, guys?
1.96. Right here. 45. Thank you so much.
Okay.
47.
And if you scroll down, if you've gone into student resources, like right here,
Point.
and you click on in-class activities. And then you click on
Yes.
part B right here, everybody. And then you click on this homework, this comes up. And you just gotta scroll down till you get here, and we're just doing writing B and C right here. Okay, so you can see that too, so that makes sense. That's it. That's the end of the worksheet. That's not the end of chapter 6,
Okay.
but that's the end of the worksheet.
Okay.
Hector, Hudaifa, Andy, makes sense? Just columns B and C. Zoom folks saying it makes sense. Let's go back to a little bit more on chapter 6. That was it. That's the end of that worksheet.
Like part two,
You can turn it in. There's no part 2.
they come up with 13 questions as a group.
Yeah, but you already did that from last week.
Yeah. I'm
You're
sorry.
supposed to have done that from last week
Okay, see.
on your own.
See that, I was asking you about that earlier. I was asking you,
Yeah, so if it's and, add them. If it's or, multiply them for your probabilities. Yes. And you guys want to take a few minute break?
Right.
Take another 5?
Yeah.
It's 13 after, we'll say 18 after, and then I'll walk you through probably the rest of 6. Or we'll cover more next class. We're still tracking just fine. You have time. It's actually till 9:50 for the schools. I looked it up.
I mean, it's 10, pretty much.
Or pretty much 10.
Yeah, when it's free in 3 hours, 15 minutes, you can round up to 10 minutes.
Yeah, rounding. It's quick. You got it.
All right, I'm gonna go regular order.
I've said it to you. You haven't seen it in a while, right?
Yeah. Dude,
You think you would notice?
I'll just do it. Because I actually feel like. Yeah, that's kind of what I want to do.
Are you getting like your tenants here?
Mm-hmm.
How's that working for you? Like, you've been in a lot of classes. Is that what you
Yeah, yeah. Well, I mean, I've just been trying to get the Associate of Arts degree. So I don't know how many credits are required for that, but how many are required for that? And then after I'll probably transfer. Some. I'm not sure.
Yeah.
I'll have to see. How about you though? I forgot what you.
But I got my sister's sexual.
Yeah.
Oh, yeah. Yeah, dude. I really can't stand it, but it's kinda hard. Male nurses, that's a guaranteed job. I got a couple friends who are doing that. It's like, I don't know, like they just need more male nurses, so it's like it's a guarantee.
En eso no.
Yeah, I don't know, I need a math class. This was like the only one I could get into.
There's other ones you could have.
I would have had to score higher on like the math placement test.
Yeah.
That makes sense.
I took general.
Oh, the giant ones. Yeah.
General math. I think I don't know what it was called. Before I took this.
Yeah, I think, I can't remember if I like, I don't know, I just know I ended up in this class and it's gonna work.
Probably good so far.
Yeah, I'm surviving. I'm hoping the exam goes good. That'll kind of determine my grade. Hey, Professor.
Yeah.
So I would think it's, what is the probability of selecting a male student given that he is an academic student, right? So would that be?
And so that'd be probability A plus probability B.
So probability that he's an academic student, and so plus the probability that he is in good grade.
Yeah, so take each fraction probability and then add them together,
Okay.
and that's how you would get there. Are the cough drops making you guys drunk? What's going on over there? Everything all right? Okay. All right.
Yeah.
Mine probably should be. I've been going since 8 this morning till now. And it's involved River Forest, Tinley Park, and Glen Ellen today. Went from 8 to 10 today. This is class number 6.
So is this like your longest day?
Uh-huh.
Oh, no, I don't know how you do it.
Well, I like my job and I don't have a boss in my case.
Yeah.
The thing that is probably the biggest challenge is at 2. Yeah, sometimes
What time do you start tomorrow?
12:20 p.m.
Oh, okay, yeah. Yeah.
till 3:05. That's all I got to do. Now I'm probably gonna go there earlier because I want to get a few things done, but I only got to work like 3 hours.
Yeah, you started at like 6 again? Oh, no.
No, I have 10 Tuesdays 10 to 10. Wednesdays. No, Tuesday is 8 to 10. Wednesdays 10 to 10. And Thursdays 8 to 10. But Mondays and Fridays are really easy.
Does your week go by faster like that?
Uh-huh.
Or the weekend goes even faster?
Yeah.
You have to do everything you can do during the week.
And whatever I don't get done during the week, I have to do on the weekend.
Mhm.
But I only have to work like 10 months a year.
True.
I went to Mexico for 17 days.
Okay, you win. You win.
Did I ever show you guys any pictures?
No, you know.
Well, let's see. So we're on slide 18.
Yeah. And they're paid, right? Yeah.
We go to 31. Yeah, let's do that.
Yeah.
Well, I'll finish explaining chapter 6. I'll show you a couple slides from Mexico, and or we'll do a worksheet, or I'll show you at the end. But I'll show you some stuff from Mexico today because I have it in like my drive, so I can just sign in. I can show you. But I want to make sure that we stay on track, so I don't want to show you now because then we'll we'll talk about the next 30 minutes if I do that. So. So this is our unit normal table. We just looked at the unit normal table. You have columns A, B, and C. So column B is the area between the mean and the Z. Or column C is between the Z and the tail. So what I'm talking about is basically, if we redraw this, if we redraw this, we should put the camera on. We'll do the whiteboard. Sure. So we have the Z-score. Then we have our mean right down the middle. And then we have our column B right here, which is between, sorry, I did not need to draw the Z, forget the Z. So you have so column A is like whatever your Z-score is. Column B is the distance between the mean, which is right here, and the Z-score. And then, so that's column B. And then column C is the distance between the Z-score and the end of the tail. Okay, so like trying to just like shade that in there. So that's C. So between Z and like your tail, that's column C. Between the mean and the Z-score is column B. And then our Z-score, of course, is basically translating our standard deviation, like from a value. Stop share. And we'll do desktop again. 4. That's what I literally just drew. Okay, so that's what we're talking about underneath the curve. Now, this is going to matter understanding what we're looking at underneath the curve, because when we start doing calculations about behavior, what we are hypothesis, we're going to use these Z-scores to tell us stuff, to like throw out or run with our hypothesis. So column A only lists the Z-scores, only lists positive Z-scores. So always, if you have a negative Z-score, just pretend it's positive, look it up that way. Column B is the area between the Z-score and the mean. Column C is between the Z-score towards the tail, like the bottom of that. So if I draw that again, not on the whiteboard, but on the whiteboard here. So column A, this is your Z-score. You got your mean right here. This, here's your Z-score. This is your mean. This is column B. And then column C is the distance to the tail, like where the tail, like this is your tail. This is your tail, okay? You could have one or two tailed test, but that's later. Don't worry about knowing that yet. So this is your distance between the Z to the tail, and that is column C. Everyone have a sense of what you're looking at? Makes sense? Don't worry about the application yet, that's coming. So the area Z-scores give us a proportion in the unit normal table. You can use the unit normal table that we just did, where we looked at the scores to look at the proportion of probability. For the score, to look at the proportion, you transform the raw score into a Z-score. Z is equal to X minus M over standard deviation. If you're talking about population, you're going to write it as theta. If you're talking about sample, you're going to write it as X minus M over SD or standard deviation. Sometimes you might see that in stats where they just write S rather than SD. I think writing SD makes more sense. It's easier to remember that way. So data indicative of chewing gum improving academic performance by mean scores on a standardized math test of 20 plus or minus 9 points. Why do we say 20 plus or minus 9? Mean plus or minus standard deviation. Assuming these data are normally distributed, what is the probability that a student who chews gum will score between 11 and 29 points higher the second time they take the test? So in this case, we have two X values, 11 and 29. We're going to transform them into Z-scores to see if they're going to score between 11 and 29 points higher. So we're going to look at the probability. So the first thing is we deal with the first variable, X is equal to 11. So we're going to take Z is equal to 11 minus 20. Where did 20 come from? Well, that was our mean, 20 plus or minus 9, divided by 9 standard deviation. So that's negative 9 divided by 9 is equal to negative 1. So it makes sense so far for the formula. So then you're going to find the score in column A of table B1. We're looking at the appendix with the Z table. And then look up column B for the proportions and find the mean P is equal to 3.413. So the B column for the standard deviation Z score is 3.413. To find the proportion between the two scores, we're going to add the 3.413 to the next score to see the difference. So we're just going to like hang on to that 3.413 number. Then for 29, same thing, 29 minus 20 divided by 9, 9 over 9 is 1, and it's the same thing. So we're going to add the two proportions from our Z score together, 3.413 times plus 0.3413, we're going to get 68.6826. No one's okay, cool. I just want to make sure it was. Therefore, the total proportion for the sum of the proportion for each score is 0.6826. So our probability would be 68.29% that they would do better because we move it over 2 decimal places, right? So the unit normal table can be used to locate scores that fall within a given proportion. So locate the Z score, transform the score into a raw score or X. So that's that formula, Z is equal to X minus M over standard deviation. So another example is in general healthy population, IQ scores are normally distributed with 100 plus or minus 15, mean plus or minus standard deviation. They said it was a population, that's why they wrote theta. Assuming the data are normally distributed, what is the minimum score needed to be in the top 10% of this distribution of intelligence scores? So step one, the top 10% of the score is the same as P is equal to 0.1000 toward the tail. So you're going to look at column C. So do that with me. Look at column C. And then you're going to see that the Z score is 1.28. Is everyone able to find that score in the table? Column C of appendix B, the Z table that we're just looking at. You're going to find, because we're talking about the unit towards the tail. So we're talking about the Z score. We're looking for the Z score towards the tail. For the top 10% of the scores, the top 10% is P is equal to 0.10000, because that would be 0.10. Because if I moved it over 2 places to the left to make it into a decimal. That's where the 0.1000 is coming from. So that's our Z score to our tail. So we're going to find that, and then we're going to move our eyes over 2 columns, the Z score being 1.28 for the standard deviation of the value of the 10%. Does that make sense, or do you want to see something else visually? You guys follow those steps. So find 0.1000 towards the tail. And the Z score is equal to 128 if you go to the left. Does that make sense? If I totally lost you guys, do you want me to show you where I'm getting that from on another screen? Okay. So what we're doing is we're going into our, where's my Z score? Z score table right here. So we're going and we're finding column C, area beyond the z-score in the tail
The right side?
on the right side. And it would be right about here. Three, eight, is that table all right? 1,000. So the closest one I have right here is 0.10003. So 1.28. Is that what they have, right? They have 1.28. Yeah, 1.28. So that's where they're getting that from. So here's the Z table. The closest Z score is the 1.28. That's not 0.10000, it's 0.10003.
The detail thing we did before the break, the 5 questions we have to, we have to.
Yeah.
5 questions. Where do you want us to submit the whole assignment? Part B, part B?
Part B, 929, part B. So we're finding out that, so if we go here, 1.28 is the Z score. If you're between them, then you try to estimate like with the number, with the half and half, we do with the numbers, but generally, because like if we were to round, this would make sense, right? We could round it down to 0.10000. So then if we go back into this. So that corresponds to 1.28. So since Z equals 1.28, you can substitute this value to the Z transformation formula. So 1.28 is equal to X minus 100 divided by 15. Now, why are we doing that? Well, we have to take X minus the mean, which is 100, divided by 15, which was the standard deviation. And then we solve for X. So X ends up being 19.2 is equal to X minus 100. And then to solve for X, we add 100 to each side to get rid of the negative. So X actually ends up being 119.2.
Okay.
So the top 10% of the IQ scores would be 119.2 in the distribution. Make sense? So then we have from binomial to normal, distribution of random outcomes for binomial variables. So mean is equal to NP and theta is equal to NPQ. What does that mean? N's the sample size, P and Q are the probabilities for each binomial outcome. WebAssign is going to give you stuff like this, and you're going to basically plug in the missing numbers if they give you like an outcome. So for this only works if N is greater than 2. The larger N is, the more closely it approximates the normal distribution. Again, bell curve. When N is equal to infinity, in theory, it's a perfect distribution. The normal distribution can be used to estimate binomial probabilities of NP and NQ are greater than 10. So for example, you select 2 participants from a population with an equal number of men and women. Random variable X is the number of men. In the sample of 2 participants, there are 3 possible outcomes, 0, 1, and 2. So this is what that looks like, 0, 1, and 2. So the relative frequency is 25%, 50%, and 25% to get to 100. So assuming they're greater than 10, check for normality, compute the mean and the standard deviation, which we can do, find the real limits. The real limits are the upper and lower values in which the probability of obtaining the outcome is contained. The real limits for a binomial outcome are X plus or minus 0.5, locate the Z-score, find the proportion located within the real limits. So this is a better example. In this case, there were 30 males sampled. Real limits were 29.5 and 30.5. And P in this case was 0.0414. But we had that. So we had our N So we had our mean and sample size P and Q are the probabilities. So when we started, so they took and they did the equation of the probabilities for the real limit. But we're gonna practice. We're gonna practice this. 9:37. Do we do a worksheet or do I talk about Mexico? Do Mexico?
Yeah.
I might have to give you a worksheet though. You don't know that I went to Mexico
When?
in
I
August.
travel every single week. Every time I picture, like, I'm on a flight right now, I'm on a flight.
That never happened.
Always traveling, always traveling. How dare you say, it never happens, you always travel.
You know why he loves traveling?
He's a part of the mafia, I told you.
I'm not part of the mafia.
He's a professor. You're part of the mafia.
So what we could do is we could do WebAssign 6, pre-test chapter 6 if you haven't already, no post-test, and then we could do more worksheets on chapter 6 in class next week.
Let's do it.
Yes.
I like your thinking.
And then I can spend
No,
10
wait,
minutes
wait.
talking about Mexico.
Honestly, we can tough it out, it's like 12 minutes, but we can do one more worksheet.
No.
You want to
no,
know what worksheet?
no,
Listen,
no,
listen,
No,
listen, if one more worksheet now means one less worksheet next week.
No,
it's
no,
one,
no,
it's one,
no,
it's
no.
one.
You know
can
what,
do it.
it's the same, I'll count him, we all wanna hear
Yeah,
about your.
yeah.
I will do the
Listen to
majority
him.
vote, I'm just saying, do the majority
No,
vote, but I'm
majority
just saying,
vote,
we can do
always.
it.
So you guys want to hear about Mexico or do a worksheet? Raise your hand if you want to do worksheets. Raise your hand if you want to hear about Mexico.
12 minutes, bro.
Okay, it's 12 minutes.
You don't want to
That's
hear
what I'm
about
saying,
Mexico.
it's like, it's 12 minutes.
Well, it's just 12 minutes. So like, if we did a worksheet or we talked about something fun to kind of round out our evening, either way, you'd be on about the same pace.
Right.
Like if we were sitting like an hour out, I wouldn't want to talk about Mexico right now for an hour because it wouldn't be a good use of your time.
Yeah.
But the fact that we're like close, so I don't know if we'd even finish the assignment. And then if you guys got questions,
Yeah. no,
My
then
brain's
that's
beyond
what-
fried, so
So I was
Good.
wondering what the worksheet.
there's no going back, my brain's already dead.
Definitely
back. Damage is done,
No, that's
damage is
actually
done.
fair, like, it's already fried, like,
Anyway,
Try and
Mexico
forward for
is-
next week, I won't suffer. Say your story about, Mexico.
Isn't that wait, is this the trip where you were like, they were trying to con you?
oh yeah.
You already told that story.
He's gonna show us pictures.
I want to show you pictures.
Oh, you have pictures.
I have some pictures. Now I have more on my phone, but I can sign into the drive, which is basically we went to like the Disneyland Xcaret of Mexico. And those pictures I can really easily access. So you can start with that. Desktop. Dude, you need to calm down, Rodaifa.
I went to Mexico. I went-
Zoom folks, did you have a preference?
Oh, yeah.
No, no,
They're not
actually,
here,
no, I
they're
think
both over time.
they'll be nice to you, right?
No. Wait, I went to Mexico.
No way.
This is my wife and I doing windsurfing.
How did you feel?
It was awesome. We went way higher than that. Let's see, we should be able to go like this.
Did you hear about the killing at the hotel?
I know, I'm clear.
Now that you're back.
Damn, man.
Not where we stayed. Did you hear about the shooting in Great America in America in
No.
Chicago while I was in
Oh,
Mexico?
no, yeah, but no, I'm being serious.
No.
He got it. He got
They had- It was like a, it was like a,
it.
what, no?
Yeah, so like this Canadian guy.
Yeah.
Oh.
Hiding in the shredded,
Yeah.
It was a parking lot in Six Flags, right? It was a parking lot.
No, we're talking about-
No, we're talking about.
In what part of Mexico though?
He said.
That
Great
hotel.
America.
The hotel, shredded,
Yeah.
This isn't a hotel. This is a theme park.
right, it's a hotel
No,
and it
that's
has the theme park.
Yeah.
Oh, then that was close to us. What date was that?
Our-
When was it?
It was in the beginning of the year, like
Yeah.
probably February, March.
Oh yeah, we were there in August.
Oh,
Yeah.
no, I didn't know, but that's, we heard about it.
I think I heard about it, but it didn't freak me out. So this is, yeah, windsurfing, which is pretty awesome. They tie you to the boat and then we went,
Were you controlling it?
no, the people in the boat were, it's like
Oh,
40
there's a boat
some bucks a
thing?
person, but it was pretty awesome. We're up
So
there.
that's where you're going.
So like they're pulling you out.
They're pulling you and you're surfing and then they drop us in the water. Like 30 or 40 miles an hour. I don't know. You go out there on a jet ski, they drop you in the water. I think they like your questions there in the back. So this is the Gulf of Mexico.
Wait, they dropped you in the water?
And then they pulled you back, they pulled us back up and then back onto the boat.
That seems scary.
Nice.
This is scuba diving, 21 feet under the water in the Gulf of Mexico.
Wait, is that your first time scuba diving?
Yeah, because they're like, you want to snorkel? I'm like, no, I want my guy card, okay? Scuba diving's way cooler.
Well, we got fish.
Yeah.
Yeah, that's the coral reef below me.
Who's taking these pictures?
Another scuba diver
There's a
with a
battalion.
camera. So yeah,
Oh my God, you're
And this
almost
was how many
like
weeks
three
ago?
this was, so we were there the August 2nd through August 7th, August 19th.
Did you just fish?
No, I wasn't able to. This is my wife is at Xcaret with this heart-shaped tree, which is kind of
Why would you
cool.
not think that-
Oh,
I
they-
mean, I was
yeah.
like so confused. I was like, it's a heart.
No, we got separate pictures and picture together. Xcaret. This was theme park. These are the underground rivers, by the way. So you swim through the underground rivers. At one point, we were swimming and they started shouting in Spanish that there was a snake on the rocks and people got out. And I was like, is it poisonous? I was like, nah, gotta protect me. It's fine. I'll just keep swimming.
That guy.
Right.
So these are the underground caves, and sometimes it opens up and you can like see the outside. Sometimes you're completely like underground swimming. More Mexico. Yeah, more of the underground water caves, which are pretty awesome. Those are actual real birds in the background. Yeah. Yeah, like those are like native.
You know what
Did you see
Spanish word?
turtles?
What?
Did you see the turtles?
We skipped that. We heard about them though. Yeah.
Do you know enough Spanish where you can like
Honestly,
like make your own way there?
I'm fluent.
That's good.
Just like the way you know Arabic, I know Spanish. Yeah.
Now I understand more Arabic than
I've never used Spanish in a business setting. No, I did. At the place that was irritating me. Because they remoted to my phone call while I was on the phone and they started telling me what to say, which was really irritating. And I used to get in trouble with compliance all the time for talking in Spanish and building rapport with people. And those are a bunch of flunkies that like weren't any good at their job. They were monitoring the sales department. So as soon as I knew they were monitoring me, I started explicitly speaking Spanish on purpose to irritate them because I was mad that they were monitoring me. So I did more of that because they'd always be like, oh, you shouldn't speak Spanish. We don't know what you're saying. So I did that a whole bunch. And then I got off the phone. I'm like, knock it off. If you want me to produce. But that was at that toxic place. So I also self-promoted my business while I was down there at the hotel on purpose. So
Wait,
it might have been a business trip. We'll see.
Hey, text right off.
Possibly. I can't confirm or deny that. So
wait, that's all the pictures you have?
no, I have more, but they're on my phone. I don't know if I can. I can probably show you guys, but I don't know if I can have the Zoom people see it. I don't know.
Put it on the-
Email it to yourself and then present the screen.
You put it on the thingy.
Oh, I could put it under the thing. Quite possibly. How does that work? Source, right? I probably have to stop zooming, right? I don't know if the Zoom folks will be able to see it, but you guys probably can. Source. What is it, like DocCam? Zoom folks, you might have to show up next time. Come on, Doc cam display on. Is that even working? And come around. Source.
Dude, it's impossible.
You're on.
Oh, wait. It might be my, wait, it might be my photos. It might be my photos, guys. Oh, yeah. Yeah, it's in the photos. All right, Zoom folks, here we go. Here we go. So can we like look at these one at a time, maybe? So this is cenotes. That's okay, I got you. PC. So this is cenotes. This is where they were messing with me on the price. These are the natural Mayan swimming holes that are freshwater. And this is my wife and I jumping in. I'm pretty sure that's, oh, that's about San Jose, Mexico. Hang on. Here it is. Is this the right one? Here we go. Quinteru, Mexico. Here we go. So this is jumping in. Pretty awesome. Yeah, this is a better picture. Cenotes. Yeah, there we go. This is like underneath in cenotes. This water is awesome. This is more that's Senior Frog. This is the boat out to Cozumel, just like the middle of the ocean.
There's something in front of you. Go back to the ball. You are money laundering.
These are
There
semis,
actual
okay?
Cash in those containers.
So this was Cozumel. This is a restaurant with a beautiful view of the ocean. This is Cozumel. Okay, this is the taco place. This I thought was hilarious. This was literally Domino's.
Wait, were those